Hey, what's up guys, my name is Cherno and welcome to Let's Make Flappy Bird. So this is going to be a very long video, probably around 2 to 3 hours, in which I'm going to make Flappy Bird from scratch, essentially. Not really from scratch, but as in, I'm not going to make a computer first, but from scratch using OpenGL and LWJGL 3 in Java. Okay, so essentially we're going to be making the game for desktop, like a full kind of screen Flappy Bird experience. I'm going to be doing the whole thing from start to finish in this one video. So at the end of this video, we will have made Flappy Bird. I'm going to be doing it all live. There's going to be like no editing at all, so you're going to see me hopefully not fail too much. And overall, it should be a great experience. So since we're kind of doing this from the beginning, here's Eclipse, which is what the first thing you're going to want to grab. This is Luna. And it's 4.4.1 in case you want the exact same one I'm using. You can get that using the link in the description below. So it'll be like eclipse.org/whatever. Anyway, see the link in the description below. And this is the IDE we're going to be using to write all of our code and test it and debug it and everything. So that in mind, when you first open Eclipse, you'll be asked to choose a workspace. So that's basically just going to be like a little collection. It's like a directory on your hard drive, which is filled with different projects. So pick a folder where you'd like to store your project, essentially, and then you'll be greeted with this. You want to click the Workbench button, and then here we go. Here's Eclipse. So the first thing you're going to want to do is probably rearrange this a bit. Set it up how you like it. This is how I like it. You don't have to do this, but you can. Under Windows Show View, I'm actually going to bring up the navigator, and then we're basically set up here, okay? So one of the things I want to mention before we start this video is I will be trying to explain as much as possible, but the reality of the situation is I want this to be one video, and I don't have 10 hours. So I'm probably going to roughly explain things and type as fast as I possibly can to get this done in a reasonable amount of time. That being said, if there's anything you don't understand or something, leave a comment below. I'm sure other people, including myself, will probably help you out. The other thing is that's really important is if you want to stay up to date with what I'm doing and certain events, because I don't want to keep posting an update video every week updating you on what's going to happen. That would be silly. So instead, I've got a Twitter account, which is just amazingly useful for something like this. So follow me on Twitter. It'll be twitter.com/thecherno. Again, link in the description. And that's probably the best way to stay up to date, hands down. All right, anyway, let's get into this. So the first thing you're actually going to want is LWJGL. All right, enter LWJGL. So LWJGL, or Lightweight Java Game Library, is an amazing thing. It's basically as this will probably explain to you, it's basically an OpenGL binding, I would say, for Java. So essentially, OpenGL is a graphics kind of specification written in C, essentially. It's actually implemented, OpenGL is essentially a specification, right? It's not actually a library that you can download. It's something that is written by, specifically and implemented by your actual GPU manufacturers, right? So whether that be NVIDIA, ATI, Intel, all those companies, they are the companies who actually implement OpenGL into their own cards and their drivers, okay? That is the version of OpenGL you're using. It's dependent on your driver, which is why there are going to be very small differences between ATI and NVIDIA graphics cards, for example, in OpenGL applications. The thing is, though, OpenGL is actually a set of standards, obviously, and specifications, so that it's not too much different. So essentially, it should basically look the same, but of course, it doesn't always, but it should. So that's the first thing you need to understand. OpenGL isn't actually code that you download. It's a specification that is actually implemented in your graphics card drivers. That being said, you're going to want to download it. So hit download. Now, release isn't actually out yet. We're going to be using LWJGL 3, by the way. So just click on stable, download that. At the time of recording this video, this wasn't out yet. I mean, it might be when you watch this, but anyway, that's the gist of things. And under getting started is basically code that we're about to copy. Not really copy, but I'm going to type a lot of this. I haven't really used LWJGL 3 too much before. So I've used 2 and whatnot, but not 3. So I actually don't know how this works exactly, but we'll figure it out live because that's how we do things, and hopefully it won't take too long. So that being said, a lot of things out of the way here. Let's go ahead and go file new Java project. So yeah, to finish off my OpenGL thing, it is essentially written in C, but the problem is we're using Java. So LWJGL is basically an interface that lets us communicate with that C code and run it. So when we call OpenGL methods, we're actually calling native code. So like C code essentially. Okay, this isn't like, what I'm saying is OpenGL in Java is the same as OpenGL in C or C++ because there is only one OpenGL. This is just a binding for it so that Java can access it and run it, okay? That's the first thing you need to understand. So let's call the project Flappy. I'm just gonna, if I can type, I'm just gonna go ahead and say 1.8. We're actually running, as you can see, that version of Java. Let's hit finish, and here is our project. Fantastic. So under source, we're gonna go right click new class. So we're gonna put it into a package called com.thecherno.flappy. So this is essentially a folder hierarchy that you set up. The dots are like slashes, so these will be separate folders, com, then the Cherno, then Flappy. Usually the convention is like your domain name in reverse order followed by the name of the project. It doesn't matter what you put here, it'll just create a bunch of folders on your hard drive, okay? So sometimes this is necessary and should be unique for things like, I don't know, if you do something for like the Google Play Store, other examples, and it's like a namespace kind of thing, but not really. Anyway, once you do that, let's hit up, we'll call our main file main, okay? The reason I call that is because it has a main method, which we will conveniently tick here so we don't have to type it, and hit finish. And we should see this stuff. Let me quickly set a few things up. So under window preferences, under general, I'm going to quickly increase the font size of both the console font and this, probably just to like 12 or something. I don't like it too big, just so you guys can see it a bit better. You don't have to do this for yourselves, obviously, but since I'm nice, I'll do that. There we go, so that's looking better. So the first thing I'm going to do is actually create two variables. So we're going to have a private int width equals, we'll go 1280, and then height equals 720. So these are going to be two variables that we create, which essentially store the width and height of our window in pixels. Okay, great. Referring to that getting started guide to actually get started. So the first thing we should do before we actually do anything is probably include LWJGL into our actual project. So to do that, right click on the folder here, hit properties, and then under Java build path, under libraries, this is what we include, right? Any external jar files or anything we need to include. So to do that, you're going to want to navigate to wherever your LWJGL extracted files are from the archive that you downloaded. You'll see a bunch of stuff here. All of it's pretty much important. So under jar, there's just one jar file, lwjgl.jar. This is what we want to actually include. So if we copy this path and then hit add external jars, we can navigate to, it's already there, fantastic. And then lwjgl.jar and just hit open. And there it is, it should be here. So under native library location, this is very important. As I just mentioned, we're dealing with native code, okay? This is just a binding for it. So we need to point Java to where that native code actually lies, okay? So under what you'll see under native and your platform, so we're on Windows, so under Windows, and then under our, so I would have thought this would be a 32-bit application, but it's actually it actually wants a 64-bit DLL. So make sure if you're on 64-bit Windows, you actually include x64. You'll see a bunch of DLL files. So OpenGL, that's for audio. We're not really too interested in that, but it's in the folder. We'll keep it here. We won't delete it. And then here is a DLL file, which is essentially a compiled library, which is LWJGL or its native code. Okay, so we want to basically put this folder under the Java kind of, look at this Java, these are the actual native stuff that you are interested in. Let me just check that I'm recording because that would be hilarious. Okay, we are good. I really hope nothing goes wrong in this video, by the way, like the audio doesn't cut out because this is a really long video and I don't want to re-record it 1,000 times. So under native library location, hit edit, and then we'll just paste in this thing. This is the folder, right? So to copy that, I've literally just clicked on the breadcrumb bar here and copy that and pasted it in. That's it. Okay, great, fantastic. Because hitting external work folder will just take forever to navigate to it. Okay, good, we've got that. Now, one thing I actually am going to do is attach the source. We do want the Java doc, but what we're going to do instead is just attach source, because the source actually includes Java doc. So again, what you'll see under LWJGL, 3 is a source.zip, so that's what we want. So if we copy the path of this folder again, double click on source attachment, and then an external location, paste that in, /source.zip, hit OK, we should have our source attached. So this is the source code for LWJGL. which is important because it contains javadoc, and I can just see how things work along the way. So if I'm not sure, because again, I haven't really used this too much, so if I don't know how something works, I can take a look at it. Anyway, fantastic. Lots of talking. Let's actually start coding now. So public void run is really what I want to start off with, and a public void start. So when our game starts, we're going to create a new instance of our main class. Just one, of course, and then just hit start. We don't even have to store that instance as an object. I'm just going to go ahead and call start straight away because that's really all we want to do. We just want to call this start method. Now that we've done that, we probably want to create a new thread for ourselves. So a new thread is essentially, so threads are just ways of doing stuff concurrently. Usually code executes line by line. With multiple threads, you can execute to multiple lines of code parallel, right, simultaneously at the same time. So the reason I'm doing this though, and I will call this our game thread. You know, sometimes you might have various threads. So first of all, if we're creating a new thread and we're passing in this as the object, obviously you can see it needs to take in a runnable. So we can basically let main implement runnable, because what it's all that's going on, right? And the reason we need this is essentially it wants a callback, right? Essentially it wants a function to run, okay? So what we do is when we call thread.start, right, this thread will actually execute, it will run this run method on this new thread, okay? So in order for it to basically know that we've got a run method, it needs to implement runnable, and you can see that. Let me quickly just attach Java's source as well, which should be where are we? Java JRE. That's not what I'm interested in. JDK source. Okay, you can see that the runnable interface only has the run method. That's it. So basically forces us to implement run, and when we hit thread.start, this will run on the new thread. That's essentially everything that's going on here. Pretty cool. So that being said, we might, like, just regarding threads, as I make this boolean called running, just regarding threads quickly, essentially you want to have your, you have to have all of your rendering on one thread, in the sense of when you create an OpenGL context, it's tied to a thread, so all of your OpenGL calls have to be on that thread. So that's why it's quite a common practice to create two threads, one for the game logic and any kind of game side stuff, and then a rendering thread, which is going to call all of the OpenGL stuff. We're not going to bother with that because this is Flappy Bird, and this is a really simple, or should be, a really simple game to make, okay? So we're not going to waste time with all that, but I'm just saying that that could be a common practice. It is a common practice. So in our run method, we have our while running loop, okay, which calls two things, update and render. So I'll make a public void update. These should probably be private, but well, I guess we should probably make them private, actually. No one else should be calling these except for this. And this is essentially our main game loop. So as long as the game is running, it will continue to update the game and render the game. We will do updates significantly slower than rendering in the future, so I like to leave rendering uncapped just so we can see performance and whatnot, but update will be kept to 60 to ensure that our logic, 60 times per second that is, to ensure that our logic is the same. We could also be working out things like delta time. I'm not going to deal with that too much because this will run significantly fast on pretty much any computer, I would imagine. There's not too many crazy things going on in this game. It's friggin' Flappy Bird, so yes. Init is going to be responsible for initializing all of our stuff. Now, remember, everything that happens in run happens on this new thread. So you cannot initialize OpenGL on our standard thread, right? By just making the constructor, for example, for main and doing OpenGL stuff there. We can't, because we have to do everything within this thread, okay? Init, OpenGL essentially, and render have to be on the same thread. So make sure that's the case, otherwise you'll run into problems. Guaranteed. Okay, so now it's time to actually use GLFW. So GLFW is a nice little OpenGL like window library thing for C and C++, but LWJGL 3 has decided to essentially make a binding to it in Java. So luckily I have used GLFW before quite a bit on in C++. So this shouldn't be too difficult. But essentially what we want to do is in init, we want to call glfw init. Now, at the current moment, we have to call glfw.glfw init. Now, I'm just not a fan of how that looks, okay, because we know it's glfw, even this has the prefix. So I'm actually going to get rid of this. So to do that, notice this is a static method as well, right? Static. Well, what that means is there's only one of it in the class, and because there's only one of it, because it's instance independent, we can just go import static, which will import everything. This thing means everything, right? It'll import every static method in the glfw class, and we now no longer have to call glfw in front of it. We can just call that, okay? We'll be doing the same thing with OpenGL. It just makes everything look a lot cleaner. Again, you don't have to, but I would recommend you do. So we should probably say if it doesn't initialize correctly, that's not actually the correct way of doing it. I think it's something like equals GL like false or something. Hopefully that's roughly correct. Let me just check this. Yes. So if that doesn't work, or if it doesn't equal true, I don't know, you can write it either way, then we should probably handle it over here, but we'll do that later because we don't really need to do that now. So again, right, we don't want to have to write GL11 or GL11 in front of it, right? So we'll just import static. And there you go. Fantastic. So that being said, let's actually create our window. So what we want to do here is we probably want to set a few window hints. So glfw window hint, so these are kind of like parameters essentially that we're setting. We're hinting glfw on how to actually create our window. So we're actually going to set resizable. I don't actually know if this stuff is set by default or whatnot. Again, I haven't really used this too much, but I assume this is, we'll just set it resizable to true, and then visible, it'll be visible, it should be visible false by default. Okay, cool, let's create a window. So private long window. So you might be asking, why is this a long? Why is it not some kind of window object? Why is it a long? This is an identifier. As you probably know, glfw is written in C. What that means is there are no such thing as objects. So instead we use kind of IDs essentially. So glfw create window, and this should be window equals glfw create window. So we'll be creating it based on the width and height, of course. We'll have a title, which I'll just call Flappy for now. Monitor and share will both be null. Okay, so these nulls are actually stored in import static org.lwjgl.system dot like memory or something, memory util. All right, and that's where these nulls are at. Right, they're just over here and they equal 0. So you could have also wrote 0. Okay, cool. So essentially this will kind of return a pointer to, like, so to speak, to, or like a memory address of this window. It's essentially an ID though. So it'll be, I don't know how it works internally. It's probably not a memory address or so, but it is an identifier for this window. So it identifies this unique window, and every time we want to do something like, I don't know, set the window position, for example, again, we pass in the window that we want to set the position for, followed by the actual position. So in OOP, it would look something like window.setPosition xpos ypos, according to that, right? But if we don't have objects, we do it this way, okay? So it's not too different, and it should be fine. And again, that's just because glfw is a C library. All right, fantastic. So that being said, let's set our window position. So what we want to do is we want to set it to be the center. So to do that, we actually have to get the current vid mode, which is glfw get video mode, glfw get primary monitor. So we're getting the primary monitor, which is your primary monitor's like characteristics essentially, such as the real one we're interested in is resolution, really. So x position and y position is all that's going to be is essentially glfw vid mode dot width. So we're getting the width of this vid mode of this one, right? So our current characteristics, we're going to get the width of it. We're going to subtract our width from it and divide everything by 2, which should get us into the center. Okay, so we're going to do the same thing for height, of course. And we are not going too quickly. I should probably start talking less and coding more, because otherwise this will take 4 hours, which is not good. Okay, great. So again, we could probably say something such as if window equals null, Again, I'm going to just put a to-do for now. So we probably want to print something. I'll return as well. I should do that here as well, so that we don't crash. But yeah, so this is if window equals null. And this should be, well, if window equals 0 or null. Okay, great. So there we go. We've got that stuff done, and this should obviously happen straight after we create our window, and everything else looks pretty sweet. So we also want to make the context current. GLFW, what is it? GLFW make context current. It's just not in our current thing. Window, so where would that be? That would be in, I don't know, that should be in here, but it's not apparently. Okay, so this, I've at one point hit Control-Shift-O and it's reorganized everything and gotten rid of my dot star. So to fix this, and so it doesn't do this, so it doesn't automatically get rid of our, or reorganize our imports again, if we go to Window and then Preferences, what you'll see under Java and then Code Style and then Organize Imports is number of static imports needed for the star, 99. So we'll change that to 1. And what that will do is Control-Shift-O, it'll prefer the star for static stuff, which is essentially what we want. Okay, fantastic. So, now that we've got that back, let's go ahead and show the window after we make it. So we'll show it. Now, we can enable vsync as well by changing the swap interval. We'll do that later though. I don't like vsync straight away because I like to measure our performance in an easy way, so we'll keep this as is for now. Okay, great. Let's quickly just write some more code to make sure this works. So if in our render method we want to update stuff, so I think it's just GLFW swap buffers, yeah. So swap buffers for our window, of course. Oh, whoops, accidentally closed that. And in update, we want to poll our events. So this will do like key events, which we're about to implement. Okay, cool. So this, while running loop though, what we want to do is we want to say in our loop that if essentially, if GL of W window should close window, so if this equals GL true, then we just simply set running equal to false. Alright, simple as that. So if we now run this, let's see what we get. Okay, so we get a screen and it closes instantly. Cool, so let's fix that up. Something is wrong, essentially. It did show our thing for a minute, so thread.start. Okay, so we probably want to set running to true and not false. I don't know why that was false, but if we run this again, we should see a black window called Flappy with our stuff, and if we close this, it should close the window. Okay, great, fantastic. So we've got something now, and we can probably accelerate the speed at which we make Flappy Bird now. So let's quickly implement input and callback stuff. So under Flappy, I want to make a new class, not interface, class called input, which will really be just keyboard, I think. I'll put this into the input package as well, just for lols. Okay, so this is going to implement something called what is it called? GLFW. Come on, give me something. No proposals. GLFW key callback, I believe. No. 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 This isn't GL. Is this defined in GLFW or something? Or GLFW callback? It is somewhere in here, believe me. Oh my goodness. Okay, so oh, it's a class. Okay, my bad. So extends GLFW key callback. So it's probably an abstract class. Yes. Okay. So we'll import that, and we'll include any unimplemented methods, which is really invoke. So long window int key scan code. So this likes to be tricky. So key is actually our key code. Scan code is not what we're looking for. So we want key because the key code corresponds with our actual keys, which aren't even written here. But I would have thought it'd be here, but no, I don't know where the keys are. Oh, they're probably just in GLFW. Yeah, here we go. So these keys, these key codes actually correspond with this key, not the scan code. So that can be a bit of a curveball, so just keep that in mind. We're going to make a public static boolean array called keys, which will be set to new boolean. I'll just set it to the default, I'll set it to the highest value that an unsigned character can represent, just because we can't possibly have any key codes higher than that. That could be a lot of memory being allocated, but whatever. That's not really that much. A boolean's only 1 byte anyway, it should be. Okay, cool. So now that that is done, when we do invoke something, right, what we want to do is we want to check the, so window, we don't really care about that. We've only got one window anyway. So under action, right, we want to say that basically keys at index key, right, if we're going to set it conditionally equal to something. So if action is equal to glfw dot glfw release, then we set this to false, right? Otherwise, we essentially will set it to true. So we're kind of doing something like that, right? Obviously, we can rewrite this as if action, so action doesn't equal glfw release. Now, the reason I haven't done it something like action equals press is because there's actually one more event. There's release, there's press, and then there's repeat. So that's when you start repeating characters. So if you hold something down, essentially. So that's why we're doing it this way, okay? It's very important that you do it this way. So, so if it doesn't equal, because release is the only event that fires when we release. So we set it equal to false if that's the case. Otherwise, we set it to true. All right, fantastic. So this is static because we really only need one of them. Why? Because we've only got one window that we really care about anyway. So there we go, done. We need to set this callback, obviously. So to do that, we need to call, once the window has been created, I'll just call it over here, glfw set key callback, so window and then the callback, which is of course our, we can just go new input. So the thing is, Java has no concept of function pointers. It's got kind of similar things called lambdas in Java 8, but for the most part, there is no way to point to a function, so we can't really have callbacks. Instead, we have to create entire classes that contain functions such as invoke, instead of just being able to pass a function that was in here. So input we could have probably created in the main class, to be honest. We didn't have to make a new file for it. I did just for organizational purposes. But again, you don't have to make a new file for this. You just need to wrap your invoke method in a class which extends callback, which has an abstract void called invoke. Okay, there we go. So that's our stuff handled. Let's just make sure this works. So in update, after we pull events, I'm going to go ahead and say if input dot keys, and we'll say, so glfw key, let's just say space, because I think we'll use a space bar probably for flapping the bird. So if that is true, we'll print out a nice message like flap. Or, yeah, flap. So if we run this and we hit spacebar, as long as it's down, we should get flap. All right, fantastic, good. So our keys are working. Awesome, we're making progress, slowly, very slowly. Let's get into some actual things. So let's just make sure OpenGL is actually working. So what I'll do is I'll quickly, in OpenGL now, I'll set a GL clear color to be, we'll just say white. Okay, and I'll also, so we'll go ahead and enable dev test. We'll need that anyway. And we'll go ahead and say, we'll print out, so we'll say OpenGL, and then we'll print out the current GL version. So GL get string, GL version. All right, and then over here, when we render, before we swap the buffers, I'll call GL clear, and GL color buffer bit, which will be enough for now. All right. Okay, so we crashed. That's fun. Illegal state exception. So there was no OpenGL context. So I assumed there was. So this is interesting. GL make context current. Oh, there's one thing we have to actually do first. We actually have to register. The context with LWJGL. So if we call GL context dot create from current, it will actually, so we've created the context in GLFW, now we have to tell LWJGL that, oh, okay, the context exists. So if we run this now, we should see nope, it's still being a bastard. So let's figure this out. So we actually have to obviously do this before we call OpenGL methods, otherwise it will not do anything. Okay, and Java just full on crashed. Okay, cool, let's start that again. There we go, white, cool, done. And just to prove it, if I change this to 0, we should get pink. So let's just run that. Pink, yay. Okay, there we go. So it is now working correctly. Fantastic. So let's also clear the depth buffer bit, because we'll need that. I don't think we'll need that too much, though. We are dealing with kind of 2D. We will have... Yeah, well, might as well do. We should probably do that anyway. Okay, cool. So I'll get rid of that flap thing. And now we can probably start with actually making Flappy Bird. So let's go ahead and get some of the, well, basically just going to spend most of this time making utility classes, because that's what we need to actually draw graphics and stuff. So I'm going to start off with maths, because that's just the, I don't know, boring thing, I guess, perhaps. So I'm going to make a class called Vector3F. So this Vector3F class is essentially going to contain all of our vector operations. So we only really need 3F. So the reason we have 3F, and you might be thinking, this is a 3-component vector, we're dealing with a 2D game, why is this the case? Is because so the Z component will be the render order, right? So we are doing depth test, which means we are actually checking for which pixels are in front of other pixels. So what we do is we say, based on the Z value, that's the render order. So if we put a bird at a higher Z value than something else, it'll be in front of that object, okay? So the bird's Z might be like 1 or 0.5, and the background might be at negative 0.5 or something. And that way the background will be behind the bird. Okay, which is irrespective of which order we actually call the rendering in, which is very important. Sneeze. Another sneeze. Okay, anyway, sneeze is out of the way. Let's set everything to 0. It will be 0 by default. I know, I'm just setting this anyway, just so that we can see what it's doing, for those of you who don't understand. So Vector3F, so another constructor, this will take in float x, y, z. And this will set this dot x equals x, this dot y equal to y, this dot z equal to z. Fantastic, there we go. So that is done. Now we could implement a variety of vector operations. This is not a tutorial on how to make a maths library. We simply don't need any other vector operations except a way to store 3 floats. So that being said, that's it. We're done. Okay. But yeah, we just don't need any of that vector maths for this series. So what I'm going to do is create a matrix 4F class now. Now this will actually have a lot of maths in it. And this will be not in input, this will be in maths. I don't know why I made math and maths. I'll actually get rid of that one, because in Australia we spell maths with an S on the end, because we're cool like that. So I'll add that to the package declaration. Alright, so we're going to actually store this matrix, which I'll call elements, as a 4x4 array, okay? So basically it's going to be a 16 float array. You can store these outside of an array, you can store this as a 2-dimensional array. You can store this as an array of vector 4Fs. We're going to be doing it this way just because, okay? No real reason. So we'll probably make a ton of constructors. We don't really need to. What I'll do is I'll make a matrix 4F constructor. I'll also make a public static matrix 4F identity. So what this will do is essentially create an identity matrix and return it. Create a new identity matrix and return it. So we'll go ahead and say matrix 4F result equals new matrix 4F. And what we'll do is we'll go through everything and set it to 0. Now in public final float size equals 4 times 4. Just quickly clean this up. In Java, everything you create as a field is automatically instantiated / initialized. So this is really unnecessary, I believe. Why are you screaming? Okay, yeah, this should be static. Obviously, the size will not change based on the instance we're at. So, this should be an integer also. So really we don't really need to go result.elements I equals 0 because that's the default, right? But the reason I'm putting this here is to show it, okay, in the code. Because yeah, okay, but just saying you don't need that at all. It'll all be 0 by default. Okay, cool. So now we actually want to diagonally set it equal to 1. Again, I'm not going to spend too much explaining maths here because it will take forever. So what you want to do is watch the Let's Make Flappy Bird series, and you want to watch the math video. I'll link it in the description. So go ahead and watch that if you're interested in why we're doing this and how it all works, because I've got like some nice animations there and everything that will actually explain everything to you. Okay, but we're diagonally creating 1. Okay, so that is an identity matrix. Anything we multiply by this matrix will be result. So A times identity matrix will equal A. Okay, so we won't change it, and then we'll return result. Okay, so we've got that now. Let's go ahead and create an orthographic matrix. So an orthographic matrix is, and again we'll make this static. An orthographic matrix is a type of projection matrix, which essentially is usually defined by clipping planes. Sometimes it can be defined by weird things like aspect ratio and field of view. Sometimes, okay, that's more of a perspective thing though. But usually it's defined by 6 clipping planes, right? So essentially we're making a box, okay? It's basically usually used for 2D rendering. It can be used for 3D rendering, of course, but the main reason it's not is because there is no concept of depth in the sense that we're used to as humans. So things that are further away, things that have a larger Z value, do not actually decrease in size in an orthographic projection. Okay? So things that are further away remain the same size, which is why it looks really weird if you're viewing a 3D scene through an orthographic projection. But it is useful for things like 2D, okay, when we just don't need that. Okay, so this is the orthographic projection matrix. If you Google this or watch my maths video, you will see what is up and what I'm doing. But essentially, I'm just setting up all this stuff. So this should be near minus far. This should be top minus bottom. All right, and then finally we need... So the reason we all need this is for our shaders essentially to know what they're doing. So if I didn't mention, we'll be using modern OpenGL, of course, not legacy. So that's why we need all this. The other thing I should mention is that what we're looking at essentially is, or at least this matrix is actually in column major ordering, which means that this is the actual, what am I saying? This is, let's see. I always forget this. No, so this is the row that we're at. So this is kind of it's the row, okay? And then this is the column, okay? So this is the third column, 0, 1, 2, which will be going down, okay? That's the order that this matrix is defined down. So this is not the column, right? This is the row, and then this is the column, okay? So again, if you watch the maths video, you will see. Left minus right. And I would recommend you do watch that because it is very useful. And it is basically mandatory to know how this works. Well, to an extent, otherwise you will have trouble. Maths is very important for game development. As if, I don't know who doesn't know that. Some universities like to imply that you don't need maths to become a programmer or a game programmer, but that is absolutely not true. So I don't know why they would say such a thing. So this should be far minus near actually. So far minus near, far plus near. All right, done. So now we will return our result. So that's our orthographic projection. I really hope that's right. We'll see when we run it, but I believe that is correct. Okay, we've done that. Now, next up, we need a few different matrices. We need a translation matrix. So public static matrix 4f translate. So this will translate, this will create a translation matrix based on our supplied vector. So this vector will be a like position, for example, and now we're going to create a matrix out of that. So matrix 4f results. So again, I think we will, what am I doing? We will start off with our identity matrix, because it's closer to what we want than 0 everywhere. And then we'll set our elements in that matrix. So we'll set a few things. So what we want really is 0 plus 3. So on the third column, we just want it, which is the last column, by the way, because 0 was the first one. So the fourth column, even though it says 3, fourth column, we want to set the top, the second one, and the third one to the components of the vector, essentially. Then that is the 1, 2. That is the that is essentially our translation matrix. Okay, or matrix. 1 is matrix, 2 is matrices, 2 or more is matrices. We need a rotation matrix. Now, the cool thing about, and again, I said matrix. The cool thing about this is we don't actually need, since this is 2D, we won't be rotating things kind of skewy and weird in three-dimensional space. So we only need it around the z-axis, which is kind of 2D rotation. So because of that, the code is much simpler. So matrix for f result. Again, we'll start with identity. And we'll say, so we'll define a few things. So first of all, we need the angle, which is that, but we need it in radians. So we're going to call math.to radians, and then angle, which is our angle in degrees. I'll also go ahead and essentially, I guess, cache the angle's cosine and sine, because we'll be using them a bunch of times. I don't want to recalculate the same sine and cosine value every time, so we'll just cache them. That'll make it a bit faster. Result elements, not matrix. Elements is what matrix is the one thing in my head, but elements is really what it's called. 0 plus 0 times 4 equals cosine. 1 plus 0 times 4 equals sine, negative sine, and cosine. Alright, so this obviously changes though. This is 1, 1, and this is 0, 1. And that's it. Again, watch the maths video for more. Okay, so that's rotate done, and then we need one more. Okay, and our one more is our multiplication one. I guess matrix. So we want to be able to multiply a matrix by other matrices. Matrix multiplication is quite different from regular multiplication. I can't see anything on my keyboard. Let me just turn the backlight on. There we go. So what we'll do is we'll say result equals identity, I guess. No, actually no, we'll start with 0. So we'll just make a new matrix for f. So yeah, matrix multiplication is quite different from regular multiplication, so I would probably recommend that you do watch the math video or go to school or something and see how it actually works, because it's a bit different, so that's why we actually need to do this. So basically each column, to get each resulting element in the resulting matrix that we get, or the matrix that we get from the multiplication, you need to multiply the row of the first one by the column of the second one, and then you add the results of each of those individual multiplications together to get the resulting multiplication. So go ahead and watch the math video. There's like a nice animation there that shows you exactly how it works. So E stands for element, which is very useful. So sum is going to plus equal. So again, you can see that we're doing this. So we're multiplying the current matrix here, by the way. So we'll go elements of the current one. I'll keep this there just to remind us. X plus E times 4 multiplied by this matrix elements. So the one that we're multiplying by, which is the right side of the equation, I guess. As in, will be our one times this one. E plus Y, so we're multiplying it against, again, the column of that. And that's it, right? So element will be going down the column and multiplying it against this one, which will be going across the columns, across the rows, okay? So there we go. And then that'll create the That'll create the resulting matrices. I don't know, the resulting matrix element. Okay, so there's quite involved, which is why the animation in my video will help you a lot. Okay, and this is obviously not. This is elements. All right, done. There we go, presto. So there is our multiply. We're basically done with our maths. What we do need though is a way to actually go from float array to float buffer. So the way we could do that is actually make a toFloat buffer method, which we'll call something called buffer utils, which we're about to invent. I know there is actually one in LWJGL. We're not interested in that one because it's just not what we need. We'll go create float buffer from our elements. So we will actually create a float buffer from an array. So let's go ahead and import float buffer first of all, and then we'll create this buffer utils class. It'll be in flappy.utils, which are all of our utility classes. So moving on to buffer utils, what do we want? We want a private constructor because this is going to be a static only class and we don't want people to accidentally instantiate it because that would be wrong. We'll create 3 different types of buffers: byte buffers, float buffers, and int buffers. So to create a byte buffer, we take in a byte array, obviously, and then what we do is we call byte buffer result equals byte buffer dot allocate direct. Okay, so the capacity that we want is actually in bytes, okay, not in elements. So that being said, when we specified length, obviously each element in this is 1 byte because it's an array of bytes. So we can just type in the length here, but for the other ones we'll actually have to probably multiply by something. Now the order we want is byte order dot native order, okay, and that's all we want. Now we're into the result, we actually put in our array, and then we return it. Now, one thing you do need to do though is actually flip the array to reverse it, because we want it ready to be streamed, essentially, or ready to be read. Okay, so that's our byte buffer. Let's now create a float buffer. So a float buffer is a bit different because floats are not 1 byte, they are 4 bytes. So in order to make this work, we take in a float array. We do still, when we go float buffer, we do still create a byte buffer. Okay, we just at the end append as float buffer, and then it will change into float buffer. Now this all looks fantastic except for the fact that it's not going to create enough. So what we want to do is actually multiply this by 4. Okay, multiplying this by 4 is the same as shifting it left by 2, because that will multiply it by 2 to the power of 2. Okay, which is 4. So I'll just use the bit shift because I'm cool like that. All right, that's the float buffer done. Finally, we need the int buffer. So the int buffer, we'll take in an integer array, and otherwise it'll do the same thing, right? We just need to obviously change this to int buffer, including here, all right? And then we'll finally obviously change this to be as int buffer. All right, that's it. So this is a pretty basic thing. Make sure you import int buffer. It's a pretty basic thing, and it's just 3 little helpers that will help us out for things like this. As you can see, it's now 1 line of code to create that. Fantastic, done. So what we need to do now is probably set up all of our other classes. So I'm going to do my least favorite first, and that is the shader class. I absolutely hate setting up shader classes because I've done it so many times, and it's, I don't know, for some reason it's just annoying. So we'll put this into utils as well. We'll call it shader utils. Okay, not shader utils. So the shader class actually won't be that bad. Now the shader utils class is a touch different because this is going to be responsible for loading in a file and actually returning essentially an OpenGL program ID, okay, or a shader ID. So what I'll do is, again, I'll make a private constructor. It's a util class. So it doesn't need it should be all static. So there'll be static int load, and it'll take in a vertex array path, not vertex array path, a vertex shader path, and a fragment shader path. So these are actual file paths. So we'll just go string vert. So this will be the actual loaded data from the string. We'll call file utils, which is a class we're about to make, to load it as string. Then we'll go vert path, and we'll do the same for the frag. So file utils.load as string, frag path. Okay, and then we'll create it essentially. So let's create this first though. Again, in utils. All right, so file utils is going to be very simple. It's going to simply read a read a string, read in a file as a string. So public string load as string. Now, what we want to do is load the file and read it line by line. So string result. Oh, okay. What we'll actually use for this is something called string builder. Now, string builder is something that doesn't recreate the string every time we append to it. Now, the reason we don't want this, by the way, is because what actually happens, right, is strings are, let me quickly just write, so this is going to actually load, it's going to read the file line by line, and it's going to load in, and I just did a bunch of stuff, it's going to load in our, by the way, if you hit Control-Shift-O, it'll import everything for you automatically. That's what I'm doing to get stuff to import stuff. Buffered reader. So this is going to load our stuff. So what we want to do is we'll create a string called buffer, right? Now, instead of just simply in our while loop where we set buffer equal to reader.readline, and we're saying that as long as this doesn't equal null, because if it does equal null, it means we've reached the end of the file and there's no more to read. Instead of going ahead and being like result, which would have been a normal string, plus equals, right? What this will do is actually reallocate the entire string again, because it's a character array, and character arrays are constant. Obviously, we can't change, they're not variable size. We can't change it, so we have to reallocate a whole new character array to hold the extra characters. String builder doesn't do that. String builder basically behind the scenes, I'm not sure what it does, it depends on the actual string builder, of course, but it will just essentially allocate a huge buffer, and it won't have to reallocate stuff because it's already allocated a lot. And then at the end, it'll just copy it down into a normal string, which is what we'll do. So it basically just saves on reallocating. So we use .append with that because Java isn't great with operator overloading, of course. And we'll close the reader at the end. Okay, and then finally we'll just go return result.toString. Alright, so the idea is, and this is a unique one that will actually return a new string based on what it is. So as you can see, it will create it based on the count, which is the amount of characters we've actually gotten there. Okay, so string builder is a very, it's great for performance, and you should only use it in loops, so don't use it everywhere because it'll be pointless for things like that. Alright, so if we did fail though, and running our file, which shouldn't really happen, but if we did fail, we'll catch an IO exception and we'll just probably print the stack trace, because the only reason we'll fail if we can't read the file, or if the file couldn't be found, and blah blah blah. We'll deal with that later. Done. Okay, so that's a quick explanation of string builder. So make sure load a string is static. Alright, and then we've got these things. So what we're going to do is return, this is the load method after all, return create vert and frag. So these shaders, right? I want to talk a bit about what shaders are in a minute in case you don't know. But these shaders are, or these strings I should say, are actually the contents of the shader file. So it's all the source code for the shader. So public static int create. The reason I made this public is in case for some reason you already have the shader as a, like in case you don't want to do files and you just write it as a string in your program, you can call the create method to create it instead of load. So load will load it from a file, create will create it from the sources. Right. So shaders are basically pieces of code which run on our graphics cards. Okay, so they do things usually concerning graphics, and just because it's a lot faster to run that code on the graphics card than the CPU essentially. And also, so let's quickly import static org.lwj. Also, essentially, you can't do certain things on the CPU, so we can't tell the graphics card where to render things on the CPU because the CPU doesn't do that. It's the graphics card's jobs. So what we want here is probably a variety of versions. So we really probably want 2.0, which is what introduced shaders. So that'll have stuff like OpenGL 2.0, that is, which introduced shaders. So that'll have stuff like create program and most of the stuff we need probably. So the vert ID will be GL create shader, GL vertex shader. Yeah, so they're basically just programs which run on our graphics card, okay? And they usually do graphics related things such as, for example, calculating lighting, you know, positioning our vertices, telling the graphics card where to render certain things and what color to render those certain things at. So it does stuff like that essentially, right? So we want to be able to write those programs to tell our game what to do. If we don't, the graphics card receives a bunch of data, which is all of our graphics data to render, and it's like, well, what do I do with this data? How do you want me to render it? It has no idea, which is why we need to write shaders and tell it. Okay, so we've compiled our shader now. We've compiled the vertex shader. Now that we've done that, we should probably check to make sure it actually succeeded in compiling the vertex shader. So what we'll say is gl get shader I, or rather we'll say if gl get shader I. So the shader that we're going to be interested in is our vertex shader, so vert ID, which is the OpenGL ID for our specific vertex shader. We'll check the compile status. Now if this equals false, or gl false, which is 0, we'll go ahead and we'll go system.error.println. The error does run on a different thread, I believe, and it's actually quite weird, but it will print in red text in Eclipse. That's like the only reason I'm using it. So failed to compile vertex shader. Now apart from just printing that, we should probably print out the actual compiler error. So to do that, we need to system.error.println gl get shader info log vert ID, and then of course, oh, we don't actually have to specify a buffer size. I don't think so. No, we don't. Otherwise, I would have put like 2048 or something. So we've compiled that. Let's now compile out. So if that works, let's return -1. I don't know. And if that did work, though, clearly we have compiled our stuff successfully, and we can actually link those two shaders to create a program. So frag ID, failed to compile fragment shader, and frag ID. All right, fantastic, done. So, we need to attach shaders to our program. So in this case, we're going to be only using two shaders, right? Vertex and fragment shaders. There are other shaders, such as geometry or tessellation shaders. We're not interested in them. We're making a very simple game, Flappy Bird, which does not need frickin' tessellation shaders, because there's not much things that we can really tessellate. So we're not going to bother with that, obviously. Okay. So program and GL validate program. Alright, return program. Alright, great. So there we go. That should be it, I believe. What we should do is once we do actually attach our shaders and link it and validate it and everything's like just beautiful, we do actually want to call delete shader. So vert ID and frag ID, because we no longer need them. They're already part of the program and everything's good. So let's delete all that stuff, just so that we're fantastic. Okay, great. So now we want to create a shader class. So this is going to go into a little folder called graphics, which will have graphical related things. So shader. What this class will do is represent an actual shader. So I don't want to use OpenGL calls. Like, I don't want to actually physically write OpenGL code every time I want to activate my shader. I want a class that does that for me, okay? So what I'm going to do is make this shader class. So this will take in a vertex and a fragment shader. These are file paths. It'll have an ID. Probably a final ID. Nice constant one. So it will go for shader-utils.load vertex fragments, right? And everything will be fantastic. So this will actually load all of our shaders for us. Shaders will be written as static instances of this class. I assume that's probably the best way to do it, actually. And everything will be fantastic. So what we want to do though is, so we've got an ID now. We want to add methods such as enable and disable, right? Which will essentially, as the name implies, bind or unbind our program, essentially enable, disable our program. So what we'll do is we'll import static org.lwjgl dot OpenGL dot GL20. So we'll go GL use program ID. Now, if ID is -1, this will actually probably, it won't crash, but it'll cause GL errors. So what we could do is simply say if ID is -1, render this class unusable, have a boolean called something like invalid or something, and then just don't check for and don't run this. We're not going to deal with that, you know. Don't watch this video if you want to learn how to make really like strong code, basically non-penetrable, non-breakable code, because we're interested in making Flappy Bird here, and that is a different ball game to making like a game engine, for example. So, yeah, I will mention things that we could do here and there, but I won't actually do them. Okay, so GL uniform. So uniform variables are essentially ways that we can actually transmit data, or I guess provide our shaders with data from the CPU. Okay, so in this case, we're setting a single integer. So essentially, if we declare an int in our shader and we declare it as uniform, we can actually give it some data from our program, from Java, from our CPU. So all we'll do is we'll say public void or public int. So I'll just call it get uniform. So what this is going to do is get the uniform of a certain shader, right? So it'll get the location of a certain shader. So in order to actually set data, we actually have to find the location of that variable in our shader, essentially. So all we'll do is we'll say, essentially it's going to be just as simple as return get uniform location ID and then the name. Okay, that's it. If that is -1, it means it couldn't find it. Okay, or yeah, essentially. So GL get uniform location. I don't know why I just did that. So we just use get uniform instead of that, and we just type in the name. That's it. Okay, fantastic. So the value is going to be value. Now, a few things that I want to note quickly, which we will actually probably do, is this returns -1. So what we want to, like it could. So what I do want to do is actually pin it to a result. And before we return it, I just want to check to see if this result actually equals -1. Because if it does, I just want to print a nice courtesy message being like, could not find uniform variable and then we'll just print the name. Alright, so I'll just, just as a little courtesy, say that we couldn't print it. Now the other thing I want to do is actually cache these names. We're going to be running these checks incredibly often, right? Multiple times per frame, okay? So a big bottleneck is actually the communication between the CPU and the GPU, okay? So we don't want it, basically, it's very inefficient for us to check the stuff we already know and actually ask the GPU what's up and then get the data back to the CPU. It's very inefficient. So what we want to do instead is actually cache these locations. The reality of this situation is that we will request a location from a shader, we'll get a response, an integer location as to where it's actually located, and then that location won't change for the duration of our program, yet every frame we ask it the location again and again and again. So what we want to do is only check it the first time, essentially, right? So what we can do is create a map, right? So what we'll do is we'll create a map of string being the name and then the integer being the location. We'll call it location cache. We'll set it equal to new hash map. So this is like one of those optimization things that I promised I wouldn't do, but I'm doing here just because it's hard to ignore. We'll import all that stuff, again, Control-Shift-O or Command-Shift-O on Mac. We'll do that for you. And then what we'll do is we'll check. We'll say if location cache actually contains key, right, being the name, yeah, then we've already got it. So we can just go ahead and return location cache dot get name, right? Simple as that, because we've already discovered the location. Otherwise, we'll go ahead and do this stuff. Okay, and we'll say once we figure out the result, if the result doesn't equal -1, yeah, we'll say here anyway. We'll say location cache. So else, I guess we'll add it into location cache. So we'll say location cache dot put key being the name, of course, and value being result. All right. Great, so it won't do that, and we'll see this in action eventually as well. Awesome, so we're getting through this. I hope I'm still recording. It says I am. Drop frame 0, cool. So it's been an hour. Okay, so we're an hour in, and we've done this much, which I think is acceptable. So I'm going to just take a quick drink, because it's very hot today. And hopefully you guys are all still following along and you're having fun. So, we need to do this for a number of different things, okay? Not just for one integer. We also want to do this for stuff like floats and other stuff. So 1f first of all. And again, the only thing that changes is really the f's and whatnot. That's it, done. We also want to create it for 2 floats. So we'll just take in float x and float y. We don't have a vector 2f, so yeah. So 2f, and then this will be xy. And then we want to do it for 3 floats. Now for 3 floats, we can actually take in a vector 3f vector, and then simply just go vector.x, vector.y, and vector.z, and then set this to 3f. Fantastic. So now that that is done, and of course we want to change this to set uniform 3f, we do need to set our actual matrices, right? So the things that we created that actually tell us important things, we want to set them into our shader. So set uniform mat for f. Matrices are always going to be floats, but anyway, we'll go ahead and we'll say, so string name, of course, and then matrix 4f matrix, and then we'll say GL uniform mat matrix 4f for alternate version of, okay, we'll call 4f maybe, I guess, I don't know. There shouldn't be a 4f. I don't know what is up. I'm just going to quickly check the source code. How is this different than specifies the value of, yes, that is correct, can transport, that's all right. Good. So how is this alternative? It doesn't check it or something? Okay, in the end it calls the same native function, value.remaining count. Oh, I see, it's got different parameters, so it doesn't have the count. I see, okay, so we'll have it figure it out. So we won't use 4f. So, okay, so location is going to be get uniform. Name is going, yeah, of course, name. Transpose false. So if we had it in row major, because OpenGL wants column major, if we had it in row major, we could change this to true and it would fix it, but or transpose it. But we've already got it in column major, so we don't need to. And the value, of course, is going to be matrix dot to float buffer. Or there we go. Done. That's it. That's how we set matrices. Okay, fantastic. So, cool. We're actually getting somewhere now. So, inside graphics, the next major thing I want to create, so we've got 2 more things to create. We've got textures and then we've got vertex arrays, and I think that's pretty much it. So, in texture, so this is a lot of utility classes. I'm sure you guys are learning heaps if you've never seen this stuff before. This is basically, it's almost like we're making a mini game engine. Well, we are, I guess, to make Flappy Bird work. Okay, so private int texture, which is going to be our texture ID. Okay, so public texture is going to simply take in a path, being the file path, and it's going to call a method called load, which is right here. Public int load string path. Okay, it's going to take in. It's actually going to do a lot of things. It's going to create an array of pixels first of all, and then feed them to OpenGL essentially. But we'll be doing a lot of reordering of color channels in a minute as well, unfortunately, because we have to. So buffered image equals image io dot read new file input stream path. Okay, so width and height. We're going to set the width equal to image dot get width, and the height equal to image dot get height. All right, all the inputs. Again, Control-Shift-O, Command-Shift-O on Mac will do that. We'll go ahead and catch an exception if we need to, which we might. Okay, so pixels. Now that we know the width and height, we can instantiate the pixels array. So we'll set it equal to new int width times height. And then finally, we need to populate the pixels array with the actual data. So 0, 0, width, height, pixels, 0, width, done. All right. Pretty basic stuff. So this is obviously passed by reference because it's an array, so it'll fill that array with the image data. Okay, fantastic. And by image data, I mean the pixels of the image, or the pixels color values of the image. Okay. So next up, we unfortunately need to actually rearrange it slightly before we give it into OpenGL. So I'll make a new int called data. And then I'm actually going to make a for loop which will go through every single integer, or every single pixel in our integer array. Extract all the channels, so pixels I, and this is the alpha channel, so it'll be here. So we'll go for all of them, of course, RGBA. So get rid of 2, get rid of 4, and that'll be like that. That'll actually, I guess we can go 0 if we want to kind of align it, which will just multiply by 1. But this is going to be 8 and this is going to be 16. So we've separated all the channels. Again, if you want to know how this works, watch the kind of texture video I had for Let's Make Flappy Bird. So there'll be a link to the description of that. That'll tell you all about all this and what it's actually doing. So we're basically just rearranging stuff. Okay, so because here is where the rearranging happens. So the alpha channel still goes in the same location as it was. Okay, we just had to extract it because we needed its data. Next we have this one. Next we have the green channel, and finally we've got the red channel. So if we read this from right to left, which is the way we kind of do read it in a way, because this is actually going to be the least significant pixels. What it used to be is ARGB, okay, or BGRA that way. Now what it is ABGR or RGBA, okay, because OpenGL actually wants this order. So it actually reads it in a bit differently. You'll see this in a minute when I actually physically type it. But we'll create the result here, which will be GL Gen Textures. Now this I believe is in 1.1. OpenGL 1.1 that is. So import static org.lwjgl.opengl 1. I guess. Yeah, it is. Okay, good. So result, so we'll go GL bind texture. So we need to bind it before we can use it. Think of it as selecting a layer in Photoshop before you actually make changes to it, right? You have to select it first. And to deselect it, we just call the reverse of it. We call bind texture with 0, and that just deselects everything, okay? We'll deselect the only one we've got selected. So this is kind of the thing we're selecting, and that's what we're setting it to, okay? So if you're binding a GL texture 2D, it will remain bound until you unbind that texture 2D. If you're binding another texture, like a texture 3D or something, which isn't a thing yet in OpenGL, I think it's in another version of OpenGL, but if you're binding something else, like 1D for example, yeah, they're like kind of different channels. So if you bind this, and then you bind 2D, you're binding two different things to two different areas. So yeah, just keep that in mind. Anyway, text parameter, so you can only have one texture 2D bound at once, right? Okay, so GL texture 2D, of course. The name, we're going to be setting a few things. We are probably going to be upscaling our graphics slightly, as in they're not going to be the same size in game as they are when we actually draw the graphics, or when we import sprites. So what we want to do is we want to control the way that it actually upscales it. So by setting this to nearest, it will go to the nearest pixel and take it. It won't blend pixels. If you change this to linear, it will linearly interpolate pixels, okay, which will cause blurring, or essentially it'll look like anti-aliasing, okay? We don't want that, okay? We want it to remain sharp. So that's what we do. All right, fantastic. So text image 2D. So we'll set DL texture 2D. We'll set, okay, so this stuff. So level 0, internal format will be RGBA. So you can see it reads it from right to left, RGBA. That's what we wanted, and we had it in BGRA, which is why it would have been a problem, okay? But we fixed it now. So width, height, border 0, format, again, GL RGBA. OpenGL has hearing issues. Sometimes it doesn't hear us the first time, so it wants it another time. Okay, now this is going to be the actual format of the actual stuff. So we basically want unsigned byte, right? We would have had these as bytes, but we can't because Java doesn't have unsigned bytes, which mean that they're signed and they range from negative 128 to positive 127. We want to go up to 255, so we have to use integers. We could have used shorts, by the way. Short would have totally been acceptable, but we went with integers, just because. So, and then we'll go buffer utils.create int buffer. And the capacity, this is the wrong int buffer. Org.LWJGL buffer util, no thank you. Create, so what was the create int buffer? Okay, so we want our one. And we're going to take in the array big data, okay? And there you go. Finally, we'll return result. Done. So, a few things we may want / need. Bind, okay? So that'll just simply bind that. So I guess we'll call bind. Except we can't do it yet because we don't actually have texture set yet. So we'll have to leave that like that. But we'll pop it here. And that'll bind our texture. And we'll have unbind, which does exactly what you think it might do. It just does that, essentially, right? So it sets it to 0. Alright, fantastic. We could have other things like get width, get height. I don't think we'll need them, so we won't do them for now. We'll see if we need them later. Okay, the last graphical thing we probably need is a vertex array. So a vertex array is essentially an array of vertices. We send that to the shader, which tells the graphics card, render these vertices here, and those vertices, of course, make up our meshes or our objects, okay? Our, like, the physical shape of our objects. So, yeah, so we're going to make a variety of vertex arrays here. So the idea here is that when we create a vertex array, it takes in a float of vertices, a byte of indices, and we'll probably need texture coordinates as well. Everything we create here will have texture coordinates. That's why I'm adding this into the constructor. So what we do have, though, is a private int, so we'll need a few things. So count. Count is going to be the amount of vertices we actually render. Because we're using indices to describe vertices, it'll actually be the length of indices, not the length of vertices. Okay, that's important. Because we're using indexed vertices, essentially. So the indices describe, so we'll get to that when we actually make them. So this will be using a lot of OpenGL versions. So org.lwjgl.opengl.gl11 will be one of them. It'll probably be using 3.0. It'll probably be using 1.5. That probably is enough. So GL gen buffers, which is 1.5. Oh, sorry, gen arrays is what we want. Okay, so our VAO is our vertex array object. So print, not print, private int VAO. Okay, we'll also have a lot more that we don't really need. We'll put them all here though. So we'll have a vertex buffer object, which is a buffer of our vertices, right? We'll have an index buffer object, which is a buffer from our indices, and finally we'll have our texture coordinates. That's big. I'm gonna name this TCS instead of, so it's smaller. Texture coordinates, texture coordinate object, I'll call it. Oops. Okay, so gen vertex arrays is what we're looking for, okay? And that's probably 3.0. Yep, GL30. Alright, so now that we've done that, we should bind our vertex array. So vertex array is just essentially, it's like a group of buffers. So we want all these buffers to be connected in a way, except for the indices really. But we want these two to be connected, right? So to do that, we put them into a vertex array, okay? But really these buffers are what actually store the data. So GL gen buffers, we'll bind it because we want to change it. So we need to select the buffer, like selecting a layer in Photoshop before we can do stuff to it. So we've selected it. Now we call GL buffer data. The target being array buffer. It's just going to be this buffer is simply going to be an array, right? Now the data is going to be vertices. Now we'll actually have to create a float buffer from it. So we just call our wonderful buffer utils.create float buffer, our one, right? Vertices. And then the usage will be GL static draw. Alright, this won't actually change dynamically, so we can just leave it as static draw. Once we set these, it won't change. Okay, great. So now we actually supply a vertex attribute pointer. So this is important because, and this is in, I think, 1.3, no. This will probably be in 2.0, I expect. Yeah, okay, because it's related to shaders, and of course shaders came around in 2.0. So the index being 0. So this stuff will make a lot more sense when we actually create our shaders. But essentially what we want to do is we want to give it, what I'm actually going to do is create some static fields for this so we don't get confused, I think. So in shader, what we'll do is we'll create a few things. So public static final int vertex. So these are going to be attribute locations. So when we create these in our shaders, attributes are kind of like uniforms, except they're set every single vertex essentially. So they're not set every time we draw something or every time we call, set uniform. Attributes are set every single vertex. Okay, so because of that, they kind of contain data such as vertex data, which of course has to be different for each vertex, otherwise we'd be drawing everything on top of each other. So we've got vertex, we'll have, the only other one we need is texture coordinate, so I guess I'll just have something like texture, I'll call it texture coordinate though, like that to make sure, and that'll be 1. These values will actually specify in our shaders when we write them, so you'll see this. So shader dot vertex, right? So that doesn't mean this is attributes. So I think I'll just go attrib, just to, because it can sound a bit confusing. It's like shader dot vertex is the vertex shader. No, it's the vertex attribute location. Now the count, that's next, right? Yep. Size. Okay, 3. Why? Because we're going to have an XYZ for each vertex. So this is going to be a linear array of vertices. So it'll be like, it'll be XYZ, it'll be XYZ, 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 XYZ. We want 3 so that we can be like, oh, okay, it has 3 components. So that's why when every 3 components, we go back to X. Essentially, we go back to the start. When we're reading this. Okay, so GL float, because they're floats. False for the, I don't even know what for. I always write false here. Let me just check what that false is for. Normalized. Yes, we don't want to normalize them. Oh yeah, they are not normalized essentially. And the last thing, which is very important, is that you actually enable this vertex attribute array. Okay, 0. So 0 because it's, and I should not have written 0, but 0 because it's that. Okay, so there we go. Great. So let's do the textures now. So the texture coordinate object, I'll call this a texture buffer object. Will equal GLGen buffers again. We'll be obviously binding that one. Create float buffer from the texture coordinates, which I'll just name TCS. I'll keep them like this. Why not? So you guys can see. Now texture coordinates won't be XYZ, they'll be XY. Obviously, when we're reading it in a 2D image, there is no such thing as Z. So we'll change this to 2, okay? And change this to T coord. Awesome. Anything else that looks weird? Not really. I mean, obviously this has to be that, but apart from that, everything looks good in the hood. Okay, fantastic. So just make sure we're not using VBO anywhere there. No, we're not. Good. Okay, so finally IBO, our index buffer object. So this will be GLGen buffers again. Okay, now the difference here is that when we bind it, this will be an element array buffer. Okay, not a array buffer. It'll be an element array buffer. So different type of buffer. And when we do supply it with data, element array buffer utils.create byte buffer indices, right? And it'll have the same usage and everything. It's just the type of buffer is different. Static draw. Fantastic. So we could unbind all these. We probably should actually. So at the end, I'll just go bind buffer GL array buffer 0 and bind buffer GL element array buffer 0. Fantastic. So now we do what we kind of did before. We create some cool things for it. So public void bind will bind our vertex array. So there's 2 things we need to bind. Our vertex array, which is VAO, and our element, so we'll need to bind our element array buffer as well. So GL element array buffer, which is our indices. So we need to bind those 2, that's it. This isn't really part of the vertex array. I should add, yeah? So I'll just bind vertex array 0. I'll put that at the bottom. All right, so this element array buffer really isn't part of the vertex array, okay? Which is why we need to bind it separately, okay? Cool. So unbind 0 and 0. Oops. Done. Okay, great. I'll just do them in this order so it looks nicer. Okay, great. So the big one here is really draw. Okay, so public void draw. What that will do is essentially draw elements. So GL draw elements. Let's see. So GL triangles is what we're looking for. GL triangles. Count. Right. GL unsigned byte. And 0. Alright, and there we go. So essentially the mode that we're drawing in will be triangles, so we're drawing triangles. There's that many of them, so this will probably be 6, right? Because we'll have 6 vertices, 3 vertices per triangle, and 2 triangles make up something like a square, which is usually what we'll be drawing. So that'll be 6, and then the type, which is unsigned byte, and then of course we've got no kind of offset. We've got no array offset, so just 0. Alright, fantastic. So if we want to combine these two operations so we don't have to call bind then draw, we'll just make a public void render, which will simply call bind and draw. It won't worry too much about unbinding here. We'll just bind and draw. Fantastic. Okay. Feels good to say this. I think we're at about an hour and a half in. Yeah, almost. In fact, not even. We've done basically all of the engine stuff now. Okay, that's out of the way, which is amazing. So now we can actually make the game. Okay? We should probably check that these things work first. Okay? We're not going to because we're short on time. We're just going to drive right into it. So I'm going to make a new class called level. This will be in the level folder. Alright, this is going to represent a level in our Flappy Bird game. So this will have a few different things. For example, it will have a private vertex array background. Alright, so this will be a vertex array, which is essentially our background, right? Our scrolling background in our Flappy Bird game. Let's make a quick constructor here. Not a quick constructor, a slow constructor. So what we'll do here is we'll actually create the background, for example. So let's make up the vertices for our background. So these are our BG vertices. I think everything else will probably have its own object, so I'm not going to bother calling it BG vertices. Okay, great. So these vertices, first thing we should do is actually set up a projection matrix. So our projection matrix, what we'll do is as follows. When we initialize all of this stuff, what we want to do is we want to create a new shader. So we'll have a shader. All of our shaders will be created statically, by the way, you'll see. So what we'll do is we'll create a public static void load all. There's a load all of our shaders, and then over here as well we'll have all of our shaders. So public static shader, we don't want to basically have more than one instance of the same shader, which is why I'm doing it this way. So public static shader, let's just call this, so background, I guess. Will background have its own shader? Probably. I'll just call this BG though. GB, garlic bread, for those of you who follow my streams and know what I'm talking about. We won't create it here. We can't create it yet because that involves OpenGL code, and we have to call load all after we've actually instantiated OpenGL, or initialized, I should say, in OpenGL. So shader equals new. So this will just be in the shaders slash bg.vert for the vertex shader, and then the fragment shader, of course, will be in frag. There we go. So now that that's done, over here we'll call shader.loadAll. Right, once OpenGL's initialized, we can call this wherever we want. So this is like OpenGL initialization stuff, as well as shader stuff. Anything related to that. Texture, there'll be a texture.loadAll as well, because again, we shouldn't have multiple instances of our textures. So what we'll do here is we'll say shader.bg, right, .set uniform map4. So the uniform, so this will be the projection matrix. And this projection matrix, all right, let me create this projection matrix here. So matrix 4f PR matrix, so projection matrix. This is what we'll call it in our shader, by the way, as you can see here. This can be called whatever you want it to be called because we'll set it here, but I've just called it the same, so it makes sense. So this will be a matrix 4f dot orthographic, right? Left, right. We know this should be a 16:9 window. I'm actually going to make it from -10 to 10 on the X. Bottom will be -16. I've totally messed this up. So it's 16:9 and not 16:10, So we'll go like this, and we'll say this will be -9 to +9, and then near and far will simply be 1.0, -1.0 for near, and then 1.0 for far. Alright? That's it. So this is what our orthographic matrix looks like. Okay? So once we've done that, once we've created it, we'll set it here. We'll have to set it for all of our shaders, most likely. Okay? So just keep that in mind. That's why I've made it an object here and not just put this in there, because we'll have to do it multiple times, I think. So, in level, when I create these vertices, I know now that -10 is the, -16 is, you know what, I kind of do want -10 to be that side. So what I'll do instead is I will actually make this 10 and 10, and then I'll simply say that this is going to be, so 10 times 9 divided by 16, right? Minus for this one. That's bottom, right? Yep. And then the top will be just the same but positive. Alright, so there we go. So now we're actually, so -10 and 10 is now that, and then well, that'll be whatever it is. Top and bottom will be whatever it is. Okay, great. So back in level, we can probably close most of these now. So I'm going to set it to -10. -10 times 9 divided by 16, 0. Alright, so this is going to be our bottom left corner. Then we're going to go ahead and create our top left corner. Now, this is not going to go all the way across the screen. I think the sprite will, the background graphic will take up half our screen. So this should go to 0, 0. Alright? I'll keep this nice and aligned though. And then again, we'll go, of course, positive and then negative again. Alright, there we go. And then the Z will just be 0, I think. At least for now. Alright? So, we're creating this out of 2 triangles. We need 6 vertices, don't we? 1, 2, 3 for the one triangle, and then another 3 for the next triangle. Now, some of these are going to be redundant. So that's where indices come in. They stop us from making redundant vertices, because essentially indices are saying that reuse the same vertices. So 0, 1, 2, 2, 3, 0 means the first triangle consists of 0, 1, 2. The second triangle consists of 2, 3, 0. Okay, that's how it works. Fantastic. So, texture coordinates, which are specified as floats. For some reason, again, I don't know. This is, I think this is an LWJGL 2 thing. I don't remember. I'm just doing it the way I know how, so I don't waste too much time. 0, 1, because remember, we're starting at the bottom. Yes, we want the Y to be 1, because we're dropping down. 0, 0, 1, 0, and 1, 1. So these are basically setting for the vertices what the texture coordinates are. Indices apply to both vertices and texture coordinates in this case. So this is going to be that 0, 0 is going to be our top left, which is exactly what this represents, and etc. Right? Fantastic. So now let's make our vertex array out of it. So it's called background, so we'll set it equal to new vertex array, float vertices, indices, and TCS, texture coordinates, right? There we go. Fantastic. So we want to draw this with an actual texture though. I'll quickly make a render method, which really what this will be doing, right? Let's just test it and make sure that this level actually does get drawn without a texture first of all. So what we'll do is we'll say in render, we'll just go background.render. Right, nice and simple. We don't need to bind it first and draw it, we can just hit .render. This will be done with a certain shader, so shader.bg.enable, so it doesn't know what shader is, let's import that, Control-Shift-O. And then we'll be nice and disable at the end, even though we don't really need to. Alright, fantastic. So, now all that remains is writing the shader to display our background, obviously not all that remains for the rest of the game. So under Flappy, I'm going to right click, hit new folder, we'll create that shaders folder that we specified in our source code over here, and then bg.vert, bg.frag are the file names. So, right click new file, not class, file, right? bg.vert. We'll write this first and then copy it. Let me just quickly boost up this text. I always forget to do that for videos. So on the basic and then text font, just put that up to 12. Alright, fantastic. So, version 330 core, what we're interested in. So I'll make it fairly compatible down to like version 3.3. So void main. So, essentially what's going to happen here for our BG is we're going to take in those two wonderful attributes of ours. So this and this, right, at position 0 and 1. So to do that, we write layout location equals 0, that's where the 0 is, yeah, in, because we're taking data in to the shader from the CPU in this case, because it's the vertex shader, so yeah, it's coming from the CPU. Vec4 is the data it is, and position. Now, the thing is, our position is in Vec3. We need a Vec4 here, but if we're giving it Vec3. That's all right, because remember we have specified in our vertex array that this is a 3 component vector essentially. Okay, so that's fine. As in, there's 3 things, so it'll just create 1 or something for the 4th one, which is fine. Because the 4th one isn't really used for positioning. Obviously, it's something else entirely, which I'm not going to get into right now. The other thing we need is layout location 1, of course, and that's our texture. So this is actually a vec2, and I'll just call this TC, texture coordinates, right? Now, we also need a projection matrix. So uniform mat 4, PR matrix. Yep, PR matrix. So it's called PR matrix. Important because it has to be the same thing that we specified here. That's the location of it. It'll get it, hopefully. It should find it. And then that's really all we need for now. So what we'll do is we'll set our GL position, yeah, equal to our projection matrix multiplied by the vertex positions. That's why this has to be a vec4. If we can take in a vec3, the other thing we could do, we can take in a vec3 and then do something like this. Yeah, personally I think it's a bit cleaner to just take in a vec4 because OpenGL will sort that stuff out for us anyway. So we'll do that. And then that's it. That's our position set up. Now we need a fragment shader, which is going to essentially give us the color of the fragment, which in this case is the color of the pixel. So we'll call this bg.frag. We'll copy and paste this for now, right? We'll get rid of most of this stuff, in fact all of it. We will have an out vec4 color. All right, we'll pop this into location 0 as well. So this will actually tell our graphics card what color this fragment should be, okay? And we'll set the color right now equal to something nice, such as, it has to be a vec4 by the way, so RGBA. We'll go like a nice blue, 0.2, 0.3, 0.8, and then alpha channel will be just 1. All right, fantastic. So hopefully this will work. We need to obviously render our level though. We're not calling this at all. So in our main, we'll go ahead and we'll go private level. We'll import that. And then we'll call in between this level.render. All right, ready? Let's see if this works. Crash. Okay, we actually got a lot of errors. So, failed to compile at vertex shader. Invalid profile core layout. What is that? So something's probably going wrong in our reading code. So it didn't compile. That's weird. Core layout. So this is probably string builder. I bet we've done the wrong thing in string builder. It's not. I think it's as string instead of toString actually. Now that I think about it. So this is in shader util. No, this is in file utils. So not toString, because that probably isn't even. Oh no, we even checked that. That should be right. Let's quickly put a breakpoint here. Yeah, let's just quickly put a breakpoint here and see. Okay, so first of all, result is core layout. Oh, whoops. So when you're reading this in, when you're appending this, make sure you put a new line character at the end of that. All right, that is the problem. Good. Let's relaunch this now. So we need a new line after every line. Okay, breakpoint. Let's ignore that and continue. Okay, level.render null pointer exception. Oh, we never made the level. Whoops. So when we do this, at the end of here, for example, we'll just go new level, and that'll of course create the object. My bad, I forgot to do that. And here we go. So good, no errors, but we see nothing. So we should be seeing a fragment. We should be seeing half our screen essentially being blue. Okay, that did not work. So now it's debugging time. The culprits are most likely. Well, first of all, this. No, that's right. My bad. So -10 to 10, -10 210, negative 1 to 1. So our matrix is correct, assuming this is right. Right, left, top, bottom, near, far. Left, right, bottom, top. Yep. Just checking maths. Maths is always good to check. 0, 1. These are all correct. These indices. Yes. Okay, so this is right. So the maths is correct. Or at least it looks correct. We never really know if it is. It's loaded the things in successfully. Let's quickly check. See, this is what we don't have time for. I was hoping we could get away without doing this. 1 hour 40 though. We're not actually making too bad of a time. We'll have to really accelerate the Flappy Bird stuff in a minute, but everything looks alright. Let's just make sure everything here is being set correctly. And it sure does look like it. The drawer is... Yeah, so are we getting an OpenGL error? That is the problem. We could check pretty easily, but I'm not going to just yet. So, let me just make sure that's all correct. Yeah, okay, everything looks fine. We've enabled our shader, which does do the correct thing. In here, let's quickly get the OpenGL error. So, GL get error. So if I doesn't equal GL, I think it's like GL no error. So if it doesn't equal no error, we'll just print I. Okay, 1282, that means invalid operation. So something we have done is invalid. It's this actually. So before we set the shader, we need to bind it. Alright, so you need to bind the shader before you set it. I might actually, and this is enable and disable. I might actually get this to do it automatically because it's going to be a lot of extra code. Yay! Half our screen is blue. Fantastic, that worked. Okay, so I might actually leave I'll change this in a minute, and I'll also leave the error checking in here because, as you can see, that was helpful. So, and what I'll do here is I'll have a private boolean enabled false. So, enabled true, false. Now the problem is this will not always work, but it will sometimes work because it relies on us unbinding everything after we finished using it, which is probably not going to happen. But it's alright. In fact, this should somewhat be static, I think. Because that will disable not just this shader, but every shader in the history. But that's alright. Oh, I gotta do it for everything here. Okay, we'll quickly do it. So if not enabled bind or enable. This is all we're going to do. Okay, I'm not really too fussy about it. This won't work every time, but it'll work for what we need it, such as over here. So, error. So now we should get no errors. Alright, good, no error codes, fantastic. So everything is fine. Now, let's get on with this. So let's give it a texture now. So what I'm actually going to do is give ourselves some awesome textures. So our Flappy, let me quickly just find my other Flappiness. So in our resources, so what I've got is, essentially I'm going to make a new folder in this Flappy Bird thing, right? I want to call it res, stands for resources, right? This is in here, so if I refresh, it'll appear here, right? I'm going to paste in a bunch of Flappy Bird assets. Now this is too much stuff, we don't need half of this. So what we've got here, if you will show me a better view, mate, extra large icons. So we've got, that's not what I wanted. Did I remove something that we needed? Probably. So there's our background, we don't need that. Where are my pipes? I specifically had pipes somewhere, and they're not here anymore, and that makes me sad. So where did you go, pipes? Where have you gone? I swear I had them. I must have deleted them. Oh no, this is not good. Things are going wrong. So somewhere, what the this is weird. Okay, anyway. So we've got some pipes that I've extracted somewhere. We'll deal with them later. I'll find them. Don't you worry. But we've got our background and we've got our bird. And I don't know what's called bird C, but we've got our bird and we've got our background. This is a JPEG for some reason, but it doesn't matter. Okay, we should still be able to read it all right. JPEG bird. So we want to apply this to this suspiciously similar sized area. So to do that, it'll be a bit stretched, but that's all right. To do that, we need to. It should be fairly easy with our current engine. So what we can do is go into our level class, private texture, BG texture, BG texture will equal new texture. Path is res/bg.jpg, and we will, before we enable this stuff and render, we will also go ahead and go not shader, bg texture dot bind, and I guess we'll call unbind at the end of it. Now, a few things remain, mainly our shaders. First thing we actually have to do is enable the whole. We actually have to set a uniform 1i being text or something. We'll call it to 1. When we do this, we want to set the active texture, because OpenGL supports multi-texturing, so it might not know which texture we're talking about. So I think this is in 1.3, but we need to basically set the active texture, so GL active texture, there it is. Oh, it's raining outside. Cool. It's summer, so that's interesting. To, like, for example, 1. Like, it can be 0, but we'll set it to 1. And if we set it to 1, we need to make sure that we set this to 1. Okay? If we set this to 0, we set this to 0. Alright? Simple as that. This is which texture we're referring to when we bind a texture. So this is the active texture. So if we want to bind multiple textures, we call GL active texture 0. We bind something. Then we call GL active texture 2. We bind something else. Right? Simple as that. Great. So that being said, back in here, we need to now make sure that our shaders actually take in stuff from the textures, from the textures. So what we need to do is, for example, create a nice struct that will send out data. We'll call it VS out, vertex shader out, into our fragment shader. So out from our vertex shader goes into our fragment shader. Okay, in from our vertex shader, in from our fragment shader takes data in from the vertex shader. All right. So we'll have vec2tc, right? And then at the end, we'll simply be setting. The reason I made this a struct instead of just out vec2tc is because we'll probably have multiple data. It's nice to have a struct, nice and organized. So we'll set vc out dot texture coordinate equal to texture coordinate. Also, it stops us from accidentally using wrong variables sometimes because we prefix everything with vc out now. Alright, great. So, that is some nice rain. I'm actually excited. It's raining outside. I feel like going out now. Anyway, what am I doing here? So, let's copy and paste this struct of ours. Structure. Put it here. Obviously, it's going to be in data. Now, this name has to remain the same, right? It has to be called data. Okay, otherwise it will refer to a different struct and we won't be able to find it, right? So, this is the name of the struct. This is the name of the... I don't know. This is our name for the struct. So we'll call this fs_in, right? So instead of taking blue, yeah, or as the color, even though it is a very nice and respectable blue, we want to actually set this to our texture coordinate, which will essentially be texture, yeah, the texture which we're about to take in here. So text is what we've called it. That's why I set it in the set uniform 1i thing in our Java code as well. And then fs_in.tc. Fantastic. So text. Let's create that. So this will simply be a uniform sampler 2D text. So this will be supplied here essentially by setting it to 1 in the BG. When we actually bind a texture, it should put it into 1. If we run this now, we should see, look at that. Fantastic. We've got our thing in our game. Awesome. We're getting somewhere. We're doing stuff. This is exciting. So we've actually got the entire game to make now, I've just realized, which will probably take a while, and we're at 1 hour 49 minutes. I'm actually confident we can pull this off in 40 minutes, okay? So let's quickly make this. Okay, I'm just gonna have some water first though. How are you guys enjoying the video so far? Pretty cool, huh? I hope so, otherwise I'm just sitting here making Flappy Bird again on a Saturday afternoon, which is the life. So, yeah, so what we want to do now is back in level. We probably want to make a scrollable background, right? That sounds reasonable. So, to do that, we're going to need quite the setup, because of course we need to repeat. We need to repeat stuff, right? As in, we need the background to be repeatable. As we move, as we move forward, this background should scroll, but we don't want to create a million different background meshes. We just want basically 2 or 3 that'll fill the screen up, and then we'll kind of loop them in a way, which will be pretty cool. So to set up a cool system like that, what we actually need to do is generate a bunch of stuff. Okay, to start off with, I'll make an integer called xScroll, and I'll set it equal to 0. Right, xScroll is going to be our horizontal scroll amount. So essentially, in our update method, which we need to actually make sure updates at a reasonable rate, we're going to increase xScroll, or rather, we're going to decrease xScroll. Okay, because of translation stuff. So we're going to decrease xScroll. All right. What's going to happen is when we actually set our, I guess, background stuff, we're going to draw it a bit differently than you might think. We bind the background, we enable the shader, and then what we do is that we actually have a for loop. So we'll render. We also need another variable. I'm gonna call it map. So I is less than map plus 4, so we'll render 4 of them. I plus plus. So what we'll do is, let me quickly just create this map. So map will also be an integer. I guess we'll set it to 0 for now. So what map is going to be is it's going to be a bit similar to xScroll, except this will be the actual, how should I say this? Kind of the location of, I don't know. This will advance the background. So I think a better name for it is probably going to be something like, I'll refactor it. I'll call this BG scroll, or BG, BG, I don't know. Map. We'll leave it as map. So what we'll do is we'll say if, so xScroll will scroll, right? And we'll use that for multiple things, by the way, not just this. But the xScroll, if the reverse of that, because obviously we're going negative, and you'll see why, by the way, because we're moving our map left, right? That's why xScroll is going negative. But if negative xScroll mod a value such as 300 roughly is going to equal 0, we'll advance our map, yeah? So we'll advance the position in which we render our maps. So what we'll do here, and 4 might be overkill, we'll see. But what I'm going to do here is I'm actually going to set the background shaders matrix, right? This is going to be the view matrix, so VW matrix. We'll set it equal to matrix 4f. They'll translate new vector 3f, and so this will be I, right, times, let's call it like, I don't know, 10 plus xScroll. All right, and then we obviously don't want to translate the map in any other direction, so we'll do something like that. And then we will, now we don't want to render it every time, because rendering, as you know, will actually bind and draw. So we don't want to bind it every time. We literally just want to bind it once and then draw it. So that being said, let's change this to draw, and then over here we'll go background dot bind. Okay, so we bind it once and then draw it like 4 times. Okay, let's see what this looks like once we fix all these things. That should not have a bracket there, and that should have an extra one here. Alright, so we need to sort out the whole update situation, because what I assume will happen is if we put level.update into here, it's going to go way too fast because it's in here. So let's just quickly, okay, it's not, okay, so we don't have a VW matrix yet. Let's add that into our shader. So this is going to be really simple, okay? All it's going to do is, it's going to be the same as this matrix, and we're going to multiply it by the view matrix. So this is like the camera's position, think of it that way. So if we were using the backgrounds, because the background's position, that would be something like model matrix. So if we run this, yeah, you can see it goes very fast. In fact, it kind of runs out of thingy, so we'll probably have to deal with that. It runs for a good while, but then it runs out. So we'll have to tweak probably this very well. So let's go back here and let's create a timer so that that only runs 60 times per second, because right now we're running incredibly fast. So to do that, let's do a bunch of stuff. So long last time is going to be system.current_time. So this is just a basic FPS counter essentially / timer to make sure our update only runs 60 times per second. Double ns equals 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a conversion from this is our tick rate essentially, but it's going to convert our nanoseconds. So we'll actually be using nanotime rather. Nanotime. All right, last time and now. Okay, so double delta is 0. Delta plus equals now minus last time divided by ns. So instead of dividing it by that, I'm dividing it by this to get it into a nice kind of format. So basically, every time delta reaches 1, we have reached. We've done it 60 times per second. So this is a bit different to delta time. Anyway, you'll see. This will work. I promise. So delta minus updates plus, and then we'll run the update here. So updates is going to be an integer which tracks how many times we update stuff per second. So that should always be 60. I'm just putting it there for debug purposes. And then frames. So here, what we'll do, well, first of all, we need to actually set last time to now, otherwise we'll get nowhere. We'll call our update there. We've done that good. Over here, we'll call render, and then we'll see how many times we called it per frame. So frames. Now this is the big one. If system.current time milliseconds minus timer, which we'll create in a minute, is greater than 1,000 milliseconds is 1 second. So what we're essentially saying is once per second. Yeah, firstly we need to actually increase timer by 1,000. Yeah, so that it does it again next second. We'll set frames to 0 and updates to 0 because we want to reset updates per second and frames per second every second. And we'll print out updates plus UPS plus frames plus FPS. How is our recording going? Good, 157, nice. So, now that that is there, we should be able to run this. Run slower. No, it's still running fast, lol. Great. So we're running at 60 frames per second, but that's still incredibly fast. Wow, okay, so this has freaking... Okay, so this is V-synced. Anyway, we'll unsync it later. This is going very fast, so let's go xscroll times like 0.03 or something. How's that speed? Looking good? Let's see if it runs out. Oh, here it is. So we'll do it again soon. Yeah. So let's boost this. We'll probably have to tune this quite a bit. I don't have time for that though, so I'm just going to try 335 and hope that magical value works. Okay, that actually looks like it's kind of working. Alright, anyway, here's our scrollable background. You can see it's scrolling now, and it will go on forever, and we're only drawing it like 4 times. I wonder if 3 will work. It might. It might not. So essentially, what it does is when it knows that this thing is out of view, it will put it over here and render it here. So that's the thing. It's rendering the same thing like 3 times in this case. Okay, 3 actually seems to work, so I guess we'll go with 3. 2 won't, because we'll run out straight away. So here you'll actually see what happens. When it gets out of this, it'll put it here. See? Cool, huh? Alright, anyway, that's our scrollable background done. So that actually was not too painful, luckily. Let's continue on now with our game. So now will probably be a good time to render pipes, but we don't have pipes because I don't know what happened to my texture. So let's go ahead and render. Let's go ahead and do the bird first, and then I'll find the pipes. Don't you worry. Under level, I'm going to make a new class called bird, not bird X, bird. And under bird, or inside bird, is going to be a lot of bird related things. So we'll create a float size, which will be our bird size, which will just be 1. We'll create a mesh for it, so vertex array mesh. We'll create a position for it, which will be a vector 3f. So we'll just instantiate that like that. So it's 0 by default, of course. Because that'll set everything to 0, as you can see. And let's see, we'll need a texture. Let's import that as well. Control-Shift-O, Command-Shift-O on Mac. We've got position. We'll have a rotation. That doesn't need to be a vector, of course, because we're only dealing with Z rotation. It can just be a float. We'll have, let's see, we'll have a delta. So this is going to be our kind of, I guess, our Y delta, I should probably call it, but we've called it that. So public bird. So this is going to be very similar to how we created our background. So I'm actually going to copy stuff from that. So in level, this is what we did, right? Bird is going to be very similar. So we've got vertices, we've got this stuff. I don't know why you indented everything, you fool. So this will be replaced by mesh. This will be replaced by texture. This will be bird.png, I believe. Am I right? I'm right. So this bird.png conveniently has transparent areas around it, which is good. It's also a bit not perfect, but whatever. We'll deal with that. Okay, so why is everything indented? Okay, so we obviously have to change this. This is basically all we have to change, by the way. These are going to be the same. So this will be minus size divided by 2. So size is going to be the whole size, obviously. So we have to go size and then from left to right, and size is going to be divided by 2. Otherwise our size would be size times 2. Minus size divided by 2 and 0. Comma. Quickly replace all that stuff with our cool stuff. Get rid of that comma at the end. I think you might be able to keep it, actually. Java might let you get away with that. And then we'll simply do this, right? That'll set our stuff correctly. So now we've got 4 vertices. And the size of our bird, which right now is 1. So that should be about the right size for this projection matrix, of course. Cool. So we'll have an update, obviously. Oops. Public void update. We'll have a render. Public void render. Okay. And what we'll do is inside here we will enable our bird shader, which we haven't created yet, but we will. So let's just do that. Shader.bird.enable shader.bird.disable and texture.bind and mesh.render. Alright, great. So one thing we should do for our thing eventually is set up the shader as well for our bird. But we'll do that later. Okay, cool. So that is looking pretty good. So we do need to actually set up our bird shader. So inside shader, I'll make another one called bird. It's going to be slightly different from the background one. Just a bit though. We need to integrate some really sweet lighting into this game as well, of course. So we'll get around to that as well. So bird.frag. I'm just going to copy these, really. Copy, paste. So bg.frag will now be called bird.frag and bg.vert will be called bird.vert. So in our vertex shader for our bird, let's make some magic happen. So I'm just thinking, I think it'll be pretty much the same for now. I will add some other changes such as lighting. In fact, this might actually just not even need its own shader, but you know, for now we'll kind of keep it in there. I'm assuming. So I think what we'll do is we will have to add in. Actually, we will need a model matrix. And we might not need a view matrix so much. So the view matrix, I'll just set that equal to an identity matrix by default, in case we don't. Otherwise, if we multiply against it and it's 0, it'll fail. And we'll set a model matrix, so that'll be 0 by default as well, but we will set it. So this will be times view matrix times model matrix times, so model view projection matrix, model view projection matrix. There we go. So this ML matrix will be set to the position of our bird. So under shader.bird.enable, shader.bird.set uniform mat4f ML matrix. I did copy it actually. No, okay. And we will set that to matrix 4f dot translate vector being our position. Awesome. So now quickly, let's just make it so that we can just move our bird in all directions, just to make sure everything is working in that sense. So glfw dot glfw key up will go position dot y minus minus. Oh no, don't do all of that. Okay, position. Is that good? Let's just import that. So this should be plus plus actually. Okay, so down, left, right. This will be minus minus. This will be minus minus. All right, cool. So we're moving this stuff around now. We'll deal with that stuff later as well. Cool. So let's go into our level. So level will create its own bird. Private bird. Bird equals new bird. And I guess after we will bird dot render. See what we got. No bird. Not good. So no OpenGL errors either. So that is suspicious. Shader.bird is a real thing, right? It looks like it. Interesting. So what do we set that to? And the position, oh, we haven't set up the projection matrix yet. That's what happened. So we need to do this again, but for bird. Basically the exact same thing, right? And we still don't see a bird. Why are you not here, bird? Okay, so let's just make sure that's all right. Shader.bird, okay, projection matrix, check. All of this position stuff, that should have been fine, right? Where's our mesh? What do we set that to? Vertices, indices. That's looking good. This is bird.png, which is check. Okay, I'm going to probably say it's because of the order we're entering this in. So let's just bring this up slightly closer to the camera. So I'm just going to put this in -1, because we're not getting GL errors, so I assume that's right. That did absolutely nothing. Let's stop rendering the background entirely. Not that way, though. Don't draw that. There's our bird. Okay, so suspicious then that bird's not rendering. We did set near to -1. So why then? That's our bird, right? Yep. So why does that work then? Suspicious, very suspicious, this whole thing. But I'm gonna just roll with it because we don't have time to debug it. Okay, cool. So there's our bird. And if we use the arrow keys, we should be able to move this. Apparently not. Why? Oh, we're not calling update. That's why. Let's go into... This is going to be very fast, by the way. This bird's just going to disappear. So let me quickly change this to like something like that. So left is minus, and so it's down. Okay, so let's quickly call update in. This is going to be the longest video I've ever put out on my channel, by the way. So I really hope you guys enjoy this because, whoa, Long video, and it's all in one take as well, which is crazy. Okay, we can move this bird now. Fantastic. Our game is looking phenomenal. Ready to ship, almost, except for the whole game part. So we should probably make that then. So, Flappy Bird. Let's start him off in... Let's do all of the bird stuff right now, except for, like, collision, because we have nothing to collide against yet. We're going to do this. So, our bird is going to be basically falling at all times. That's just what he does. He's a Flappy Bird. He doesn't really know how to flap unless we press spacebar, and I'm typing what I'm saying. Fall. So, what we'll do is we'll just... The delta, right? That's the amount we're falling by. We're going to set that to minus, like, 0.15 or something. That should be about right, I think. We're in level. I knew something was off about this whole thing. So, fall. So we will get rid of this. We don't need that anymore. That was just for testing purposes. So, fall. Delta is that. Okay? What we're going to do is say... Oh, actually... No, we won't do that yet. We will do this. This will be a static fall, which we'll do when we actually lose the game, actually. I've just decided. So, what we'll do is we'll say... we'll go real simple. We'll say position Y is going to be subtracted by delta. Okay, so we're going to fall based on the delta, whatever that may be. So right now, if it is that, and we fall, we'll just go down like that. So this should be positive, but anyway, we'll go down, I promise. So if we do flap though, if input dot keys, let's just make this a touch better, huh? Let's go in here and say public static boolean is key down int key code. This will just return keys key code. I think it'll just look slightly better when we use it. Okay, there we go, done. So if input dot is key down glfw dot glf. So we'll import glfw statically, static. There we go. So we don't have to prefix that all the time. So if so key spacebar, right? So if that is down, right, we'll go ahead and we'll actually say delta. So we want it to fall at an increasing rate. So I'll probably just say something like, if we do actually hit spacebar, we'll set it equal to like -0.5. So we're going up at about that rate, as I just showed you via fall, right? That should be probably good. Otherwise, we want to constantly be falling by probably about that much. That should be about right. We might tweak that a bit. So if we run this now, and what is up here? Get out. If we run this now, it should fall, but if we hit spacebar, you can see where, oh look, we're basically playing Flappy Bird already, because the map is advancing, which makes it look like the bird is moving, even though the bird is not moving at all. He's just going up and down. In fact, if I were to not animate X scroll at all, this would look weird. Well, okay, there's something quite wrong when we're actually closing the game, so we'll probably should fix that later. Anyway, weird how our map just disappeared. Oh, because that's always 0, that's why. So this looks quite weird. It looks like we're just going up and down, but if you suddenly add the magic of animation, it looks like we're moving. Alright. Now, one thing that's happening right now is we're getting a white background, okay? What we need to do, it's very simple. A, we actually need blending, but B, if we go to bird.frag, and we check, we say if color.w, which is our alpha channel, so XYZ is RGB and then nothing past Z, so we go back to W. If color.w is less than 1, we can just discard. And that will discard that fragment completely, okay? So if we launch that, okay. That's weird. That should not have happened. This is in bird, right? If color.w is less than 1, Discard. Why did that discard our whole thing? Oh, obviously because we haven't set the color yet. Lol. So there we go. So that fixes the whole thing. So that kind of gets rid of the whole OpenGL blending thing, because it's just simply saying don't draw that particular pixel or fragment. Yeah. So there we go. So now our bird looks better. Now we need a bit of rotation to make this look a bit better. And looks like our map is kind of bleeding. It is. Okay, we'll fix that later. So if color.w, yeah, so we've got that down. Now what we need to do is probably add a bit of rotation to our bird. Okay. Now luckily, we've got a fantastic way to rotate our bird. All we need to do is we need to go ahead and say rotation is going to probably equal something like minus delta times about 90 degrees or so. Okay. So because negative delta is going to be roughly in the range that we're looking for. So if we go ahead and this translate, right, we're going to go ahead and multiply it by a rotation matrix, which we create just by specifying this. So if this doesn't work, it's probably something to do with our rotation maths, but hopefully it will work. Awesome, look at that. So that's pretty good. You can see the faster he falls, the more he tilts down as well, which is fantastic. And look, he's like flapping. All it's missing is some flappy animation, which I'm sure you guys can add. But there we go. So we've got Flappy Bird kind of working pretty well, I think. That's good. In fact, everything's pretty much done in this class. What we do want to say is, for a game over, we'll do something else as well. But it's looking pretty good right now, and we're at 2 hours and 15. I thought I'd have this done in 15 minutes. Probably not, but yeah. Okay, okay. So let's make the pipes now. So let me quickly just locate my pipes, because something has happened with them, and it's not terribly amazing. Okay, so here's my pipe. There you are. I found you. Luckily, because that would have been awkward if I didn't. Flappy, resources, pipe. Look, here it is. Fantastic. It's also alphaed. Cool, right? So that we don't have that stuff. Fantastic. So, pipes. I'm going to make another shader for the pipes. I know I'm making shaders for everything, but the reason is I'm taking the safe road, because I believe that we probably will need differing shaders once we add lighting, because maybe lighting will be different. I don't know. For now, we'll just keep it like this. When we add a new shader, the most important thing we do is give it the right parameters. So, pipe, pipe, pipe. I also need to do that cool fade-in shader that we had at the beginning of Flappy Bird every time you started, as you guys probably remember. From the preview at the beginning of this video. So, there we go, pipe, done. Okay, good. So, pipes, how do they work? Pipes are static, that's one thing we need to note. Pipes will actually need their own shaders, actually, because they, some of them will be inverted, as you'll see. But the way that pipes will work is, they'll be level, they'll kind of be static, in the sense that this pipes don't change. They're the same pipes over and over again, right? So we don't want to have a new instance of them for each pipe. So what we do instead is we have basically a somewhat static class. Each pipe will have its own position though, so we'll blend this stuff. So position equals new vector 3f. We'll have a static float, okay? So this will be the width of the pipe, which I'm going to say it's set to about 0.5, and the height, which I'll set to like 8. That should be roughly correct. Our width of our screen is 20, so I think we'll play around with the height a lot, I think, because unless that just happens to be perfect, because we'll probably need to make it either. It might be too difficult or too easy, depending on, because Flappy Bird, the difficulty really depends on you know, stuff. So we'll have texture. So right now, you might notice that textures are being loaded in not statically, like I said they would be. That's because I don't actually think we'll need to load, like we don't have multiple instances. So yeah, so we'll have this matrix 4f, which will be our like PR matrix. No, sorry, not PR matrix, ML matrix. And finally, we need a mesh, so that'll be static as well, because that won't change. So we'll pop all of our static stuff down a bit. Okay, great. So over here, we'll go ahead and we'll make a public static void like create or compile or something. We'll call it create. where we set up all of our stuff. So back in Bird, let's go to Bird quickly, copy its stuff, paste it into here without the indentation, please. Oh, well, as long as it's easy to fix, I guess it's fine. So yeah, so we'll just start off with 0, 0, 0, 1, I guess. And then we'll set this stuff accordingly. So we'll go with we'll go 0, 0. So we'll go down the bottom, width, width, and then we'll just do height like this. All right, everything else stays the same. We can probably kind of static this out as long as everything's this kind of shape, but it's all right. We'll leave it here. Mesh, and then of course the texture will be pipe.png. That is correct, I believe. Yep, pipe.png. Fantastic. So there's our stuff. When we do create a new pipe, though, public pipe, we'll probably take in an X and Y. So you guys might be a bit confused because there's a static method and then we're making other stuff here, but you will see, don't you worry. So position.x equals x, position.y equals y, and we need to create a matrix out of it. So matrix equals matrix, sorry, not matrix, we called it ML matrix, equals matrix for f.translate, of course, and it'll just be based on position, that's it. I don't actually know if we'll need this, we might, we'll see. So, this will be, yeah, this is the model matrix, and of course, it'll be translated based on the, we will need this stuff for collision detection, actually, now that I think about it. But this will be translated on, because remember, the camera's moving as well as the actual pipes have their own locations, so yeah, we will need them. Okay, we're going to need a bunch of, I'm going to make a position public. I could. I'll just to make it explicit for you, I'll make getters for the position things. The reason I'm doing this is because when we start writing the collision code, which will just be a simple rectangular collision thing, it'll look better, basically, if you guys can see what's going on. So, public static vertex array get mesh, return mesh. Do the same for the texture. Create the texture, yep. Okay. And so we'll probably render it out actually in the other, in level, I think, because we have to render it multiple times and stuff. So public static float get width. These are just the static because the width and height doesn't change, as opposed to x and y. And height, we'll return height. Alright, this is quite a long coding session. Are we hitting 3 hours yet? 2.5 almost. Ooh, we're getting this. Okay, so back in level, I'm probably less excited than I was at the beginning of the video, to be honest. But back in level, I'm going to actually make a render pipes method, which will be in charge of rendering pipes. So public, we'll make this private, void render pipes. So we'll enable the pipe shader, of course. So shader.pipe .set, let's set our matrix, right? This will be our, so the view matrix will be set to shader, string name. The view matrix will be set to essentially like our view matrix. We might add some parallaxing in if we're cool, and we are pretty cool, so I think we will. But we'll keep it the same as this for now. Instead of obviously I times 10, we just have X scroll because there is no I. We're not rendering multiple times here. So we need to bind the texture. So pipe.getTexture.bind. We need to bind the mesh. So we are actually doing this. We're not calling .render. We're going to be calling bind and draw because we're gonna do it kind of the same thing here, how we do it multiple times. So for loop time, for in I equals 0, I is less than, how many pipes are going to fit on the screen? I'm going to say 10, so 5 times 2 in the sense of 5 there and 5 on the top, 5 on the bottom. That's 10, I believe. My math is correct, of course it is. Okay, so now that we've got that, let's go back to shader.pipe.setUniformMat4. So now we will be saying, mat4f will be setting the model matrix, so ML matrix, to the pipes model matrix. So pipes, we need to create pipes, and then we need to get their model matrix. So what we'll do is we'll have a public matrix 4f get model matrix return ML matrix. All right, cool. So let's create these pipes. So the cool thing about this is we only really need 10 pipes. Yeah, we really only need 10 pipes because the thing is these pipes will be reused, they'll be recycled. So private pipe array pipes equals new pipe, and we'll just have 10 of them. So we don't even need dynamic arrays. So I'll just write 5 times 2 so it looks better. And it's more clear, I guess. So 5 times 2, 5 on the top, 5 on the bottom. Those are our pipes. And then once we, we'll be able to recycle them the same way we do with our map, which is awesome. So I will, in the constructor here, we'll probably just have like private void create, or like create pipes or something. We'll call that from the constructor. And what we'll do is we'll say pipes. So this will probably be created. Okay. Pipes will be, this will be update pipes, I think. And you'll see the difference. So we'll have a generate pipes. I won't call them, I guess we'll call them create pipes. So this is the initial one that we run, just to, instantiate each object and whatnot, I guess. So for int I equals 0, I is less than, like 5 times 2, I guess, or the length of it. We'll say pipes I equals new pipe. Now this is where the fun begins. So we probably want to say something like, this is going to be hard. Well, not too difficult, of course, but still hard. Okay, here is what I'm going to say. So here's what we'll do. We'll pop it at. So we'll have an index. Private int index. We'll set that to 0. What we'll do is we'll create the pipe at index times like 3. We want to set it at a random. We'll put it to 4 right now. This is going to be the top pipe. Now we need to make the bottom pipe. So we'll go I plus 1, right? So when I say 5 times 2, I do want to say I plus equals 2, okay? And we'll need index for something else. That's why I've made index, and you'll see that in a minute. Because we do want to actually plus equals 2 to the index as well. You'll see that in action later. It's all in my head right now, and I can't explain it yet. I want to show you. Okay, so over here, when we create this, what we'll do is we need to create it at the same x as this. Okay, so instead of hard coding it, I will say pipe equals new pipe, pipes I, which is the one we just created, dot get x, right? So it's the same x, it needs to be aligned. Yeah, it needs to be aligned in terms of horizontally. And it'll be pipes, it'll be whatever the y is. Yeah, which is 4 right now, minus like 10. Okay, that should generate our pipes fairly well, and we'll update them later. Let's just make sure this gives us something cool. So create pipes. So when we render them, we'll render this stuff. So we'll set this equal to pipes I dot get model matrix. And of course, we also need to actually render them. So we need to let's see. Yeah. So pipe.getMesh.draw. Alright, and then let's unbind both the texture and the mesh. Unbind, unbind. Not bind, unbind. Alright, fantastic. So, let's give this a whirl. We're not calling render pipes though, so let's do that before we render the bird, I'd say, and see what this looks like, if anything. Ooh, a crash. Is it a, what crash is it? It's a null pointer exception. So what's null? I'd say texture. Really is the only thing that could be null. So get textures returning texture. Oh, create. This needs to happen. So we need to actually call in here before we create the pipes here. Or in fact, as we're creating the pipes, pipe dot create. All right, and then we'll call that. And voila! Oh, look at that pipes. That looks amazing. Our bird just fell though. Come on, bird. You still alive? There you are. Yay! That is way too hard. First of all. Let's say, okay. Let's make the gap a bit wider. Okay, that's still a bit too high. We want them to be at random intervals though, don't we? So let's create a random, private random equals new random. So this is where the fun part of the game begins, when we actually get to, you know, create stuff and experiment, and there's no like frustration or anything. Well, in a way. So we'll, to this times 4, I'm just gonna go random.next float times like 4. See what that looks like? Okay, that's actually really good. The only problem is our textures are not inverted when they should be on the top. So this is actually looking pretty good, and it's already infuriating me how silly this game is. So we're actually getting somewhere, because, okay, so the pipes don't loop. That's to do. But let's fix it. Let's fix the texture first. So it's going to be a pretty easy fix. I'm going to, under render pipes, simply make a quick, we'll set a uniform, like, I don't know, what do we have? Just a one eye, I guess, which will be called something like whether or not this is the top, essentially. So, if, the way we check for this is we say that if imod2 equals 0, then we're at the top, right? So we'll set this to 1, otherwise we'll set it to 0. Simple as that. So, top. Let's create that in our fragment shader for our pipes. So pipe dot frag. We'll have a uniform uniform int top. Okay, so if top is, I don't know, 0, that means it's false, right? So if top is 1, what we want to do is just invert the texture. So I don't think we can actually set dot y equals 1 minus. I don't think we can actually do that. Like, it'll yell at us for modifying something. Oh no, it didn't yell at us. It didn't work though. But it didn't yell at us, so what have we done here? Texture coordinate dot y equals 1. Oh, minus texture coordinate dot y. Yay, there we go. Inverted. Alright, awesome. How cool is that? And if you switch it to 0, you can really get some crazy things going where nothing is correctly oriented. But there we go. So that's a really easy fix. We just flip the texture coordinate, that's it. You could have flipped the mesh, rotated the mesh. That would have been worse, I would say. So yeah, let's draw the bird in front of the pipes as well. Actually, I'm getting a bit frustrated by that. So we'll go 0.2. Alright, and now the bird should be in front of the pipes. Fantastic, there we go. So, now all that's missing now is some collision. That starts off, I mean, the other thing is we start off inside this pipe. So let's fix that, and then let's fix the pipe generation. So 2 things we have to do, and we're actually almost done, which is cool. I think I can finish this easily in half an hour. So this will be a 3-hour video, incredibly long, but whatever. We made a whole game, so whatever. From scratch as well, pretty much. So let's go to level. That's what I'm looking for. I've got too many things open. Let's close everything. So in level, let's create some kind of offset. So let's go private int offset equals, what should we set it to? How about like half the screen or a quarter of the screen? Go a quarter of the screen. So 5 is a quarter of the screen because 20 is our whole thing across. And this should be a float, I guess. And we'll go offset plus on the x. So that should pretty much fix that problem. There we go. That's pretty much perfect, I think. So I'm not liking this. It's probably because we're not terminating GLFW or anything. So let's go ahead and say after this, we'll just go GLFW destroy window, and then GLFW quit or end. There has to be a GLFW quit. Let me just quickly check the wiki and whatnot. Although by wiki I really mean terminate. I mean the getting started guide, because the getting started guide is surprisingly useful, as you can pretty much imagine. So yeah, GLFW terminate. All right. Anyway, let's see if that fixes that problem. Yeah, I think it does. Okay, great. So now that we've done that, we need the hard part, which is some, I guess, maths and trial and error, which is the updating of the pipes. So basically, we need to loop through all of our pipes whenever this is called, which won't be all the time. We need to I don't think we do need to iterate through everything. What we do need to do, though, is say pipes index. So we'll change index. Index is our little index here, which we will change. But index mod 10, right? Because we don't want to exceed the bounds of the array, and index will be much bigger eventually. New pipe. So we'll create the same, literally the same pipe, I think. The offset will probably increment as well. Oh no, we won't, because index is there for us. So this is actually probably going to be easier than I thought it would be, because we've got a pretty good setup here. And then of course we have to do the same thing for the y, so +1, or that, so that we don't get crashes and everything. In case we're at 11. I don't think we will though, but anyway. We'll do this. Offset. Let's see. So this will be the same as this, I believe. So we're kind of regenerating them, is what's going on. Yeah. Looking pretty good. Except for I, which is just going to have to be that. All right, done. And then of course we do need to remember to increment index, because that's what's kind of telling us how far along we are and whatnot. Okay, good. So now that we've done that, index. Oh, actually, no, we even don't. I think this might work. We just need to call update pipes at the right moment, essentially, which is going to be interesting. So I think we will call create every time. Oh, this is going to be... I'm just going to make a wild guess here, and hopefully it works, but it might not, which is why it's interesting. So we'll say if so -scroll. Just count that. I think 250 should be about the first time we need to do it, and -xscroll is mod like 100 is 0, and we'll call create. And by create I mean update pipes, because create is our other thing. Oh, it's actually called create pipes. It's even wrong. Man, let's see what happens. We should probably speed up the bird. Oh, that's wrong. So it's happening way too quickly. 120. No, that's still too quick. Okay, so scroll minus. I'm just thinking. Let's What if we... Because why is it already that high? That's what I'm wondering. We shouldn't have reached 250 just yet. But we have. Which makes me suspicious of something. Not sure what though. Okay. Well, I guess we'll just tweak this. Oh, almost. That'll be too much. Okay, let's increase this though. So let's make this like 280. This will be much harder actually. Except that ruins everything. Because it probably doesn't stop through that. So, that's annoying. Alright, I guess we'll just have to test it the hard way. Okay. This tweaking is going to take a while, and that's, unfortunately, we might not meet our video when, what are we, 2:40. 2 minutes 40 seconds, according to my thing. Okay, that's wrong as well. But you can see we're regenerating pipes, basically. So they're just happening too quickly. So let's make this like 335, maybe. Same as the map. Alright, that's still too... It's almost right. Oh, hang on. Now it's right. Now it's gonna stop. So that's... There we go. Interesting. Alright. So... That's looking alright. Okay, so that's looking alright so far. And that's pretty good. Let's add a fourth map. Just in case. I think that'll fix our issue. And then I want to add a bit of parallaxing in. So I'm going to set this to like 0.05. So now the pipes move at different rates to that, as you can see. They actually move a bit faster. Which will probably mean that we run out of pipe soon. Like there. So we probably need to decrease this. I want to put it back to 120 and see what that looks like. Yeah, so now you can see the pipes are moving at a different speed, which is really cool. I really like what that looks like. I think it's cool. And in fact, the pipes look like they're generating perfectly. I knew 120 was a good value. But yeah, so you can play around with that, and you can make this like 0.1 or something. So then the pipes will move much faster, and it'll be very hard. And you can see how like different it is from this as well, which is pretty cool. So play around with that for sure. But I want to keep it on 0.5 because everything looks cool like that. Cool. So there we go. Flappy Bird. That's quite hard actually. Let's do this. Let's put this to like 11.5 maybe. So that's our kind of difference here, that distance. Yeah, that's easier, but not by much, which is good. Collision time. So collision is going to be easy, kind of. So because it's just we're going to collide the mesh of we're going to just collide the bird against the pipes, so it's going to be pretty easy. So it's going to be a boolean, simple boolean result. If we collide, we're dead. We don't need actual response, collision response or anything. So for each of the pipes length, which so there's 10 pipes, of course. So for the pipes that are currently on the screen, let's just extract a bunch of values because I really want to. It's really important that you see what it looks like. So first of all, bird x. That's our first one. Our bird x doesn't change. It's 0 all the time because the bird is always in the center. So what we actually need to do is check essentially reverse, I guess, the pipes. So we need to grab the pipes in a way. So the pipes x, kind of. So we go minus x scroll because we want to grab the reverse of it. Because x scroll gets decreased while this should increase. That way we can get the birds, is what I'm saying. Because really what we're comparing is birds to pipes. So the y will be the actual y, because the bird does have a y, which is not actually there yet. So let's create that method. and I'll return y. Or should I say position.y. And then we need a width and height and whatnot, so we'll also get the pipes x at this point though. So the pipes x will be just pipes i.getX. And then this will be the pipes y as well. So we've got the x for the bird and the pipes. Great, now we need all the widths and heights, or the, I guess, second x and y. What? A whole lot of stuff. So what we can do is we can actually get the first bird's x point, I guess, by grabbing the bird's x. So this is going to be the left bound of the bird. It's going to be bx, or bird.get, of that thing. I'm splitting this up into as many variables as possible just so you can see it clearly, okay? Bx minus, so the size of the bird, right, divided by 2, because when we created it, we don't have get size. Return size. When we created it using size, we went divided by 2, so that it goes from negative size divided by 2 to positive size divided by 2. All right. So when we do go bird.get size, y. So we'll do it for all the bounds. So this will be plus, right, for the right side of the bird, and then this will just be minus and plus again for the top and bottom bounds, right? Okay, so the pipes x bound is going to be the pipes x, because we didn't do it using that way. We didn't really do it using kind of AABB style minus plus whatever bird size divided by 2. Px1 is going to equal that plus the static width of the pipe. And look, the height is going to be, the y is going to be exactly the same, right? Except for its appropriate things. Fantastic. So there we go. All we have to do now is check these against each other. So if the bird's right side is bigger than the left side of the pipe, right? And the bird's left side is less than the pipe's right side, we're inside the pipe horizontally, or at least touching it. And then if this is the case, then, oh, well, the same for y, and I think using, yeah. So the reason I've set it up this way, because this should technically be like plus or whatever, and then that should be minus because this negative is down, but I've set it up this way just to make it so that we can quickly and easily do this kind of comparison. We'll return true, otherwise we'll return false. Not inside the for loop though. There we go. So this collision should pretty much be all we need. So you can probably put this down into just this. These are just here to help you. That's literally it. So if we go ahead and inside update, so if there's a collision, we'll print out collision just to see what is up. Now if we run this and we hit collision, good. Let's try that one, collision. What if we try going through it? Oh, I hit it. It's too hard. Okay, no collision there. There was a bit of collision there. Oh, this is difficult. Okay, that one. Whoop. Okay, that looks good. Yep. So it is difficult, but there we go, no collisions there. Alright, fantastic. So everything's working in the collision department. Now we actually have to handle the collision. So we want to play a bit of a... I like playing an animation where the bird kind of bounces and then just falls. Okay, so what we want to have is... I like having a, like a private... Maybe a private boolean called control. So we'll set that equal to true. So this is whether or not the player is in control, right? So if there's a collision, we need to do a bunch of things, right? We need to say control is false. Player's lost control of the player. Player's lost control of the bird, which means the bird will just eventually fall. So the other thing we want to do though is set this fall thing that I made. We'll set the delta. Let's make that public and let's just call it. This will look pretty cool, I think. Let's just try and hit something. Boom. Oh, it flew away. Oh, but it went down again. Okay, so if the collision happens, then, so if control is true, we don't want to do it multiplines. If control is true and collision happens, there we go. So the bird kind of bounces up, as you can see. If I let go, boom, and then falls to its death, and then that's it. We probably want to stop scrolling as well. So, if control, do all that. Otherwise, don't. There we go. All right, cool stuff. So, that's looking pretty good. What else? That's like it. I mean, one thing I'm actually not going to do is add sound or text, because adding text to this would require like it would require us to make a font sheet and probably get that to load and whatever. And I think if you guys really want that, I can make a Flappy Bird extensions video, which will just have a bunch of other stuff, like maybe a menu and stuff. But for now, I think that's pretty good. So if we hit spacebar again and we're dead, it should probably reset everything. So we'll make it do that. Simply probably by creating a new level if we're lazy. So what we'll say is, if it's, yeah, we'll do that in a minute. Man, this is looking pretty good, and we're on to, well, this did take a while, to be honest. I was going to try and do it in like 2.5 hours, but we're already 20 minutes over time. Anyway, the point is, this is looking pretty good. I'm thinking, is there anything else I wanted to do? Oh, there was a fade in at the start, in the thing I showed you. So let's quickly make a fade shader. This will actually be different from our other ones though. Fade.frag, fade.vert. So this fade shader, right, this cool fade shader, is actually going to be, I'm actually going to just create the geometry in here, because I can't be bothered creating a vertex shader for it. We don't even need that. So what we'll do, this will be very basic. So void main, I'll say const vec for vertices. We'll make 6 of them, obviously. This will fill the screen. So what this will be is, so we'll have a vec for like 1.0, negative 1.0. We'll set up a different projection for this as well. You'll see. So come on. Okay. So, first triangle, second triangle will just be negative, negative. Oh, wait, no, positive, negative, negative. Takes a while to get used to knowing all these values, believe me. But it's alright if you mentally sketch it out, it'll work. So this will be that like that, and then that'll be like that. This will always be negative. So this is the, it should be overlaying. I'm not sure why it looks like our near and far are switched. I'm going to investigate the maths behind our thing. I bet I've just screwed that up. That has to be, it has to be the orthographic, the matrix for f.orthographic method. Vertex ID. So we still need to send a render call for 6 of these, and it should be a normal draw arrays, not draw elements, to get this to render. But I put this in the fragment shader. Whoops, lol. Okay, we want this in the vertex shader. Okay, so there's our cool stuff. Okay, now this is where it's a bit different. We need to fade based on the time, kind of. So, and we do need actually to probably enable blending in a minute. But out vec for color, just pop this into location 0 just to make sure. I mean, it should work, but anyway. Then we'll probably take in a uniform float time. So, if time is greater than 1.0, we can discard and we can just forget about rendering completely. Now, otherwise though, color is going to equal vec4, so it's going to be white in the RGB, but this will be 1.0 minus time. So as time increases, after it hits 1, it'll be gone. So it starts at 1, and then the opacity just decreases until it hits 0, because after 0 it'll get discarded. Fantastic. So now that we've done that, we need to set up 2 things. In vertex array, we need a way to draw public vertex array int count, this dot count equals count. So over here in bind, we only bind, so if IBO doesn't equal, if IBO is greater than 0, because it could be -1, I guess, we'll do that. Same here. And in draw, if IBO is greater than 0, we'll draw elements. Otherwise, we will call draw arrays. Mode GL triangles. Let's see. First, 0 count. All right. And then I guess we'll generate a vertex array. I don't actually think we need to, but we'll do it. Okay, great. So we should have that. Now we need to set up the whole fading stuff as well. And by fading stuff, okay. First thing I'm actually going to do, to be honest, before I do anything, is fix my maths. Orthographic. Let's take a look at you once more. So, that does look right. Far minus near. That is correct. Near far. Near minus far. That's right. Suspicious. That should be correct. But yet it's inverted, kind of. Near far. Oh, I probably just set them the wrong way. No, I don't think I did. Weird. Okay, it doesn't matter. We'll deal with that later. So let's duplicate this obviously and create it for our fade shader. We've got a lot of shaders. We don't need the text for it, of course. Except the projection matrix for fade will be different, which you'll see in a minute. So fade. Alright, so the matrix for fade is going to be a touch different. Let me just think about what I want to set it to. Probably negative, like we set the, where are we? We set this from -1 to 1, and yeah, so it's just going to be -1 to 1, essentially, right? So we'll go matrix for f dot orthographic -1, 1, -1, 1, -1, 1. That should be fantastic. So in here, let's create a background fade. Fade will be a new vertex array 6. Put it up here. We will fade.render. We need a time. Private float time equals 0. In update, time plus equals like 0.1, something low. That might be too much. That might be too quick, actually. 0.01. Fade.render, and then we have to supply it. Shader.fade. We'll enable it first of all, and then we'll say shader.fade.set uniform 1f time value is time. Alright, let me just double check that shader. Yep, that's good. Let's just see what this looks like. So white, and then it should disappear. Okay, cool. So we want it to blend, and it couldn't find PR matrix. Oh, we don't need a projection matrix if we're, my bad. We don't need a projection matrix if it's, because that's the default projection matrix. So there we go. Fantastic. So Blending. We need to enable blending in OpenGL, otherwise it won't actually blend. As you can see, the alpha doesn't actually matter. It will, yeah, it won't blend on like semi-opaque things, basically, or semi-transparent things. So when we're doing this, what we need to do is we need to basically do a few things. First of all, we need to enable GL blend. Now that by itself probably won't work. Nope. But we need to specify essentially the blend function that we're using. Okay. So GL source alpha and GL1 minus source alpha will, there we go, give us a fantastically nice fade in, as you can see. Awesome. Looks pretty good to me. And we're straight in the action as well, which is cool. So there we go. You don't have to use that, but I thought it would be a cool kind of blingy thing we'll add. Alright, finally, we're down to the last thing we need to do, and that is optional, but cool. Okay? We want to add lighting. So how are we going to do that? Let's add it to the background first, because I think that'll be the biggest kind of thing. Okay? So the first thing we want is we want it to probably be based on the position of the bird, I would say. So let's just say the lighting follows the bird. So to do that, first thing we'll do is, in our background, essentially what I want to do is, in our background vertex and fragment shaders, so in the vertex shader, we need to take in the current position of the actual background, okay? So, but not inclusive of the projection matrix. Alright, so if we grab the view matrix and whatnot and go vec3 position, we want to grab vsout.position equals vec3 that times that. And if we put it in constructor, it'll just trim off the fourth component, which we don't care about. And then here, if we go vec3 position, we will basically light it based on the position and also the bird. So we need to take in a bird. We need to take in a bird. Quote Cherno 2015. But seriously, we need to take in a bird. Okay. So this bird we'll get from our other thing. We're going to say that color times equals like 3 divided by the length, so the difference between these vectors, bird minus fsin dot position, we're really interested in xy, I think, plus like 2.5, and we'll set it to about, I think that'll be cool. So we will have to set a minimum here, otherwise it'll be totally black if it's too far away, which actually will look pretty cool and demonstrate our point perfectly. So I am going to show you that in a minute. But there's our vec2. So that's why I made vec2 in shader. The center uniform vec2. It was for the bird. Okay, so back in level, when we enable this shader, what we want to do when we bind the background is actually set uniform 2f name bird xy bird dot. Okay, so the bird's x is just going to be 0 as far as the background's concerned, and the y will be bird.getY. Alright, magical. So, if we were to test run this, we would see that wherever the bird is, the background, okay, so what's cool is it actually goes to grey instead of black, which is very cool. And I, of course, did that on purpose, but I like that. Okay, cool. So I can't even get past the first one. I'm terrible at this. What I will do is I will add about 0.3 or so. And what that will do is just make sure that you can see, we can still see the texture at the end. Yeah, if we go too far away, it will still fade out to grey. Okay, but it won't look too bad. So one thing we should do is set our clear color to probably 0. If we get rid of this, it'll just do that as well. So what that'll do is it'll make it black instead of grey. Yeah, because our clear color was white before, and also our pipes don't have lighting, which looks weird. But you can see that that looks pretty cool. I kind of like that. So yeah, you can keep it grey or whatever if you want. Oh, and we can actually still play. If we hit this, we can still bounce. We should get rid of that. So to quickly get rid of that, in bird, we'll say, are we hitting 3 hours yet? My God, my goodness, we've hit 3 hours. If keyboard and control. So now once we die, we're dead. Oh, control is in the other thing. That is annoying. I don't even know what to do with that. Okay, we'll just leave it as is, I think. That looks really nice. I like that lighting. So let's make it apply for pipes as well. So for our pipe, we'll go into background. We'll copy bird and stuff. So let's paste bird in. Let's paste in position. And we're going to have a very similar color thing. Now, we want to do this after we potentially discard it. Otherwise, of course, the alpha will probably change. And then we won't, yeah. It might even go higher or whatever. It might be modified. We want to discard it first and then only do it to the pixels that we don't discard. Cool. So we also want to change the vertex shader to include this. So pipe.vert vec3 position. All right, and back in level, we want to this shader.bg thing when we render the pipes. We want to do that. That's it. Let's test that out. Cool. So now the pipes have lighting as well. This is kind of a scary. And you can see the alpha, by the way, the pipes are kind of transparent, which is interesting. So we do not want it to affect the alpha channel at all. So to do that, or to not affect the alpha channel, we can just simply apply it to everything else. So what you could do, in fact, possibly the simplest way of doing this would be simply to just set color.w equal to 1. And that would make sure that they wouldn't be transparent, and you can see that they'll kind of go all dark and stuff. They are actually a bit bright, so I might set this to like 0.1 or something. You can tweak these. This is why I created different shaders. No, they're a bit... No, that's not bright enough. Is the bird being set properly? Interesting. Because they're not being lit at all, actually, those pipes. Huh. Maybe I'm not setting the position, but I am. Oh, this should be model matrix times. Oh. There we go. Okay, so now we go. And see, you can see the pipes are being lit now. Right? So there we go. So this is probably better now. Okay, so now let's bring this back to like 0.2. Man, this game is furiously hard. I'm never gonna play my game anymore because this is just, what have I created? Let's set this a bit higher, so like 12.5. This is for like noobs like me who need it to be easier for development purposes, of course. So there we go. So this is like a kind of Halloween freaky Flappy Bird thing. If you wanted to make it more subtle, right, you can just increase this. So if I put that to like 0.4 and I put this to like 0.4 as well, that'll be the minimum. You can see it's bright. Everything's like a bit brighter, including the birds. So we can probably fix that a bit by tweaking this. If we put this to like 1 for the background, say, we'll get a much more subtle effect. As you can see, that's possibly too subtle. 2 maybe. Anyway, have fun tweaking the lighting because it is a lot of fun, and we can probably bring this up even more. There we go. So that's much more subtle now. I actually kind of like that. The pipes look like they're being overlit as well, so 1 maybe. That'll be probably 2. How's that lighting? That lighting is basically non-existent. 2. I actually think the distance could probably use less modification in this case. There we go. So we get a bit of like specular kind of off it. Alright, that's looking good. Everything is a bit dark though, so maybe 0.6 and 0.7 or something. There we go. Awesome. Okay, so we've got a bit of lighting in Flappy Bird now. It's looking pretty good. Yeah, I mean, we're pretty much done. The only thing I don't like, and literally the only thing I'm going to fix at this point, is the fact that we can still flap after we kind of died, and also I want to reset everything. So what I'm going to do is I'm going to say, instead of making it so that the bird can't flap, if, so level will have a, public boolean game over, return control equals false, is game over. iOS game over is game over. So what we'll do is we'll say, this will be interesting, but in update, if is game over, level equals new level. Pretty crazy, and would be probably responsible if this was multi-threaded or something, but I think this will work out fine. So, okay, that's not good. So, no. So control reset equals false. So, basically, what I'll do is I'll say if no control and input dot is key down GLFW key space, then reset equals true. Let me just import that statically. Import static org.lwjgl.glfw.glfw.star. Fantastic. There we go. So now we hit reset true, and then this will be not control and reset. So essentially we could just return reset. So now if we collide, we're good, and then if we hit spacebar again, we restart. So play around with the lighting. It's probably not perfect. You could probably tweak it a bit. But there you go. You got Flappy Bird, and you can play it as many times as you want, and you can cry. So I would probably set it if I was... This was like totally production release or whatever. I'd probably set... I'd probably add some lighting to the bird or something as well, but I'd probably set this to about 11.5, I think, instead of 12.5. Because 12.5 is easy, even though I'm failing at it. You can play around with the... Yeah, see, that's the infuriating level that you're used to in Flappy Bird. Also, this is a bit easier because you can actually hold spacebar. So you can make it so that you can't hold spacebar. That would be infuriating. But yeah, so you can do whatever you want, really. But yeah, up to you. Anyway, I like how fade plays again as well. That's nice. Everything gets reset. Cool. So, any questions? Leave them in the comments below. Make sure you follow me on Twitter, twitter.com/thecherno, so you don't miss anything. I stream pretty regularly on twitch.tv/thecherno, so you can always catch me there as well. And if you want to know if I'm streaming, just follow me on Twitter, you'll see. And please hit the like button if you guys enjoyed this video, because it is 3 hours and 13 minutes long right now, and it's just massive. All of this code in its current state, in its current non-perfect state, I mean, it's pretty good, I think, will be pushed to GitHub as soon as I finish recording this. So in other words, it will be over at... you can find, well, there'll be a link in the description first of all, but you can find it over here under a repository which will be called just Flappy. It'll just be called Flappy. Okay, so feel free to look at the code there, and hope you guys learned something. And as I said, please don't forget to hit the like button if this video was enjoyed by yourself, or if you got something out of it. I hope you did. Again, any questions, leave them in the comments. I'll try and actively answer those comments. Let's quickly handle this stuff before I... So we'll just push... Whoops. I don't know what I did there. So we'll do that. And then could not create window, GLW window. Alright, and that's pretty much it. No more to-dos, I hope. There shouldn't be. Alright, cool. So, any other questions, leave them in the comments below. Hope you guys enjoyed this, and I will see you next time. Goodbye.